Yeah. Okay. Hello and welcome to this ECIR 2021 tutorial on search among sensitive content. So we are all working with large collections of data, and most, if not all, of these collections of data will have some form of sensitive information hidden in them somewhere. Sometimes it's not so hidden. So this sensitive data obviously protected so that we can interact with the data safely. So in this tutorial, we'll be highlighting lots of aspects of this problem and discussing sort of many ways that we can go about interacting with this data and making it available. So I'm Graham Mcdonald, and I will be presenting the tutorial with my colleague Doug Oard. We also have our website. The URL is in the bottom of the screen there. If you go to the website, you can get a reading list to accompany the tutorial, and the slides are also available there. Okay, so a brief introduction about us. As I said, my name is Graham Mcdonald. I'm from the University of Glasgow. So my main research interests are sensitivity classification, so different approaches to actually identify the sensitive information that needs to be protected. And part of that is sort of active learning strategies to integrate the reviewer, a human reviewer, into the review process. So there's a lot of parts of that we'll talk about, but what it really involves is a sort of technology-assisted review process where it's a decision support scheme. And we've been working with the National Archives in the UK, which is the official government archives, and different government departments. And I'll be telling you more about that as we go along. Hand over to Doug now.
Very good. So I'm Doug Oard. My main research interests are in searching various kinds of human language. So probably best known for my work on cross-language information retrieval. But speech retrieval has been a long-standing interest of mine. And when working with searching speech, you run into sensitivities almost immediately. We have different social construction of confidentiality around spoken conversation than we do around much of written conversation or written interaction. And so that led me to this question of how do we search when there's intermixed sensitive content and content that should be found. And so that's the problem we'll be talking about today. We're not going to principally focus on speech, but that's sort of what led me to this. I'd like to invite people to turn on their cameras. I find it's much more enjoyable to teach when we're all together and can see each other. So if you'd like to turn on your camera, please do go ahead and do so. We are being recorded. But we will not use the recording if you ask us not to until after we edit out anything that might involve someone other than us. So entirely your choice how you want to proceed there, but we're a small group right now, and we can perhaps be more informal if we can see each other. Here's the outline of the day. So the times are all in European time. And we'll be talking first some background here, and then we'll about evaluation. It's a little odd to talk about evaluation before we talk about what we're evaluating, which is why the background section is there. But because we do machine learning to an objective function, we have to have the objective functions defined. So it's convenient to think about how would we evaluate the task quite early in the discussion. We'll then talk about detecting sensitive content and then protecting sensitive content, sort of the order you would expect. There will be a break someplace in there, which we'll take at 4:15, even if we're in the middle of talking about protecting sensitive content at the time. It's a half-hour break. And then we'll come back to talk about some other issues that didn't fit cleanly anywhere else in the presentation. And then a quite fun period, 30 minutes or so at the end, where we'll break up into subgroups where we can be even more interactive, and we'll have some design sprints. So you can think of this as choose your own ending. You can either go off with Graham or you can go off with me, and we'll tell you closer to the time about what we're doing after we've introduced the ideas. But essentially, one of them is going to be focused on evaluation, and the other one focused on design. Then we'll wrap up and we'll end by 6:15. I'd encourage you, if you have questions, to put them in the chat. When I'm teaching, Graham will be monitoring the chat and vice versa. We can answer questions at the end of each of these blocks. You're also welcome at the end of each of these blocks to just speak up and ask questions. You've got control over your own microphones. And I would invite you to just interrupt us with questions along the way. If they're brief questions, not going to take us off into a half-hour discussion on a point. That way we can be sort of maximally interactive. So as background, we all have secrets. We all have things that we wish some people to know and other people not to know under some circumstances. There's a fellow who used to live here in the state of Maryland, who's now moved to California, who invites people to send postcards with their secrets. He then posts their secrets anonymously on the internet. It's called Post Secret. It's great fun. And so you can see all sorts of things that people send in. One of the cleaner ones is on the left here. And then, of course, other people have other ways of conveying their secrets. But the problem is that the secrets show up in places where you might wish that they don't. This is a problem that has been called in social media context collapse, where different contexts in your life show up all in the same place. The place that we see this very clearly is in email, where people have their work life and their personal life together. And then some people keep separate accounts, many people don't, and even people who do keep separate accounts, other people send messages to the wrong account. And so you'll end up with this all mixed up. And that's not really a very big problem because email is personal. It's not made public, but of course, sometimes it gets made public. Here's the Enron email on the left, and we've searched for information on a nightstand, a bedside table. And you can see in the first message here that perhaps the person that sent this message about the one night stand was not imagining that this was going to be the first result that came up when someone did a search of the Enron email on the internet. We need to be mindful of the rights of many people, not just the people who have the content, the people who have interests in the content, perhaps because they created it or perhaps because it's content about them. Now, you might think that that because email is personal and not often shared, it wouldn't be that much of a problem. But of course, sometimes email becomes of great interest. It's actually rare for a month to go by here in the US without email being mentioned on the front page of our major newspapers in some context or another. This is perhaps the most famous recent example. This is from about 5 years ago now, where we had a Secretary of State, Hillary Clinton, who was running for president. And so this was of great national interest. She had about 60,000 emails that she had assembled over the time she was Secretary of State for reasons that are a little complex. The State Department didn't have the emails. She had them personally, but she agreed to release them. And before releasing them, her lawyers went through and removed those which they believed to be personal. Now, no one double checked them because they removed them and no one has seen these emails, but that was about half of them. And then the State Department here in the US hired 50 people who worked for 10 months with several other government agencies, so additional people, to review all of the 30,000 or so emails that remained, finding another 1,200 that were personal that had been missed, and some that contained national security information that never should have been an email in the first place. And they released the rest of them, about 26,000 emails, but it took them about 10 months to do that. Now, as you might imagine, this was just the Secretary of State's email over a 4-year period, but the State Department itself generates about 1 billion emails every year. Now, it's just not possible for an organization smaller than the State Department itself to review all of those emails. And so they will never be segregated in this way. And thus, they're not retained by the US government. So we have no access to the email that moves around the US government, and we never will, because the State Department does not maintain its email, and for rational reasons, because there is no way to separate the sensitive content from the content that should be seen. And that's frankly our fault. We are in the business of building search engines that find things that should be found, and we aren't able to support this sort of an information access problem. And so that's largely what the tutorial is about talking among ourselves about what the state of the art is, what the nature of the problem is, what remains to be done. Now, here's a second problem. The US government has quite a lot of information that it maintains. So I just told you about information it doesn't maintain, but it maintains quite a lot of information that it can't share for national security reasons. And then over time, that information becomes less sensitive and eventually gets reviewed for release. The problem is that, of course, generating the information has a higher priority than releasing the information. And so there are limited resources available for review, and those resources need to be deployed to review the things that are of greatest potential interest. But how would we know what's greatest potential interest if nobody's ever seen it, right? I mean, we know people are interested in UFOs, but there are lots of things that we just have trouble guessing whether people are going to be interested in it. So if we could let people search among the sensitive content, we wouldn't have this problem of having to simply blindly go through and review things in some linear order. We would be able to find the things that people wanted to see. All right, so that's just an example. It's an example from government information. But there are lots of kinds of information that might be sensitive, and people have tried to sort of write down what might be sensitive and codify it somehow, and they've made formal specifications of these things. So one example is the classified information that I was just talking about. But health information is very heavily regulated. In the US, it's regulated under a regulation called HIPAA that tells us what we can and can't do with information about people's health status. And of course, this is important because if we could use the large troves of information that we have in electronic health records, there's kinds of health research that could be done on those records. And so there are specifications that are very precise about what sorts of things you can use and for what purposes. The General Data Protection Regulation, GDPR in the EU, regulates access to personally identifiable information in ways that are much more nuanced than we have here in the US, and much more specific. And so all of those are rather well specified. And that's actually what people think about when they think about the sorts of things that we're talking about today, is they think about, for example, removing credit card numbers from collections. But there are many other kinds of things that are regulated. And so, for example, we'll talk today about the Freedom of Information legislation in the United Kingdom. which has specific exemptions of things that can't be released, but they're not a formal specification. It doesn't say you can't release something with a person's name in it, for example. Rather, what it says is you can't release things that might damage the foreign relations of the United Kingdom. Well, I mean, that's a pretty broad category that requires interpretation. And so we're going to have to think about how can we build machines that can exercise judgments about whether content has a specific nature to it. Well, that's what we do all the time with topic-based retrieval. So this isn't very far from what we do. So you can think of these as sort of categorical descriptions, or in the lingo of information retrieval, these are topics. And so attorney-client privilege is another one that comes up particularly in the United States, where such things are often litigated and needs to be protected for encouraging attorneys and clients to have open communication. The right to be forgotten in the EU is not formulated as a categorical protection, but its motivation is formulated categorically. And so we could provide a right to be forgotten with technology that is broader in scope than the present right to be forgotten that's codified in GDPR. However, even that doesn't begin to cover the full scope of the problem, because the person who wrote about not the nightstand, but the one night stand isn't on any of these lists. That's a matter of personal privacy, and that is highly contextual. It really depends on who they're sending the message to. They actually wanted the person they were sending the message to see the message, but they didn't want other people to see the message. And they cared quite a lot at the time they were sending the message about that, and they might care quite a lot less now, particularly if they've passed away. And so personal privacy is this very complex construct. And so all of these things exist together in these collections. This is that context collapse I was talking about. So we could step back and ask, what have people already done? What do people know about this? And this is a project at the Stanford University Libraries in California that is ingesting email from famous people. For example, from poets, Don Knuth from our field, wrote The Art of Computer Programming, is one of the people who contributed emails to this, and I'll show one of his emails later on from this system. But they built a, and in it they put some categories that they could automatically detect using very simple classifiers, just word lists, that would then prompt a conversation between the donor and the archive about which sorts of things in their email should be protected. And so we can think of that as a beginning of an ontology that comes from practice now. This is just for email, which we're just using as sort of this brilliantly good example case where all these problems come up. But it's a nice way of thinking about what kinds of categories we have. Because they're in California, they actually had two categories of drug use. One is legal drug use, like prescription medications, and the other is illegal drug use, but I figured I'd fold those together for the purpose of the rest of us. Some colleagues of mine and I did some work on talking to donors of email collections to archives and talking to archivists about what donors were concerned about. So this is sort of trying to go a step beyond that list from EPAD. And you can see here some things that people were concerned about. For example, someone whose grandfather was in the Ku Klux Klan, which is, well, it's a somewhat socially stigmatized membership for good reason here in the US. Or indiscretions of various kinds. So for example, people don't want to have a reputation for gossiping, but people gossip. Well, okay, so they'd like their gossip to be protected. People get into professional disagreements, and they'd prefer that their dirty laundry not be aired. Well, there are many things you might not have thought of on these lists, and also different people have different sensitivities. So just because it's on this list doesn't mean everybody is sensitive about it. It just means somebody is sensitive about that. But for example, I'm not sensitive about 2 or 3 of the things on this list in my own email, but I'm sensitive about things that aren't on the list in my own email. So anyway, it's a complex picture that we can begin to get a bit of a view of. So I want to come back to this question of who has interests in what we're doing. The searcher has interests in what we're doing, and we're very well equipped to think about the searcher's interests. I mean, we build search engines to serve the searcher. In a normal search engine, we just assume that all the content wants to be found, and we try to do the finding on behalf of the searcher. So we're quite used to that. The owner of the content has interests, and those are the donors that I was talking about. They have 2 interests. One is they want their content used. And the other is they want their sensitivities protected. And these interests, of course, are in tension. But the original creators of the content might not be the people who are presently holding that content. And they have interests, and we don't even know what they are, right? So we have to act on behalf of people we've never met. We can't ask them questions. They may no longer be alive. And there are people who are talked about in the collection who have interests. So for example, when we were trying to protect the national security information in Hillary Clinton's email, the goal there was to prevent from being killed, right? So there's stuff in there about maybe spies. Those spies are off doing things. If people knew they were spies, they might be killed. So this is not low stakes stuff, right? This is not that, you know, I have a disagreement professionally with somebody and you're going to find out about it. And these people, they didn't write the email. They didn't receive the email. They don't have the email, and they're not searching for the email. They're simply mentioned in the email, and we need to be careful about that, right? And so we'll spend a little bit of time talking about all of these stakeholders today, and how we could protect what we believe to be their interests. But the question of how we know what their interests are is another problem. Now, I've been talking as if the goal here is to either show you content or not show you content. And in fact, today, we'll take that perspective quite a lot. But that's not the only perspective. And so at points during the day, we'll drill down a bit further, and we'll look at the question of which parts of a document can we show you. And this is a very common activity to remove certain parts of a document. The people who want to remove social security numbers from documents, that's the national identifier here in the United States, they're not trying to remove the entire document, they're just trying to remove the number. And so you can see here Porter Goss, he's a former director of the Central Intelligence Agency. He's testifying to Congress here, and he's got some document in the background that has all of these redactions on them. That's what we call it when we black something out. This is a really fun article from a satirical newspaper here in the US called The Onion, in which they're pointing out that the CIA has for years been trying to use highlighters to emphasize the important parts of documents, and they just discovered the mistake. So I don't think it was actually a mistake, but in any case, the Onion casts it as a mistake. And that's what we're going to do. We're going to try to use black highlighters on the things that we don't want people to see. And that's a problem, so-called redaction. So we have 3 core tasks. This is the last slide in this background section. These are the 3 things we're going to talk about today. One is we want to detect documents that contain sensitive content. And having detected the documents that contain sensitive content, then what we want to do is we want to detect the sensitive content inside those documents. And knowing which documents contain sensitive content and which parts of those are sensitive, we then want to serve the user by finding relevant documents without exposing sensitive content. If we were only doing the first two, this would not be an information retrieval tutorial. This is an information retrieval tutorial to find documents that are amidst things that shouldn't be found, right? And so these are the three problems that have to be addressed. And so according to our schedule, we've got some time for questions. And this is a good time to talk about what it is we are going to talk about, and also things we haven't identified to talk about that you want us to talk about. The floor is open for questions or comments. Graham, anybody showing up in chat?
Nothing in chat, nothing in Wova. From what I can see, it's quite quiet.
Okay. Well, we invite you to think as we go about what it is we might be saying that that's worth discussing, and we will press on. And so in the next section, we're going to talk about how we would evaluate how well we're doing. And I want to do that in three ways. One is I will start by talking about three public test collections, just to get us thinking about what would a test collection for this problem look like. It's a standard way that we think. And then Graham will tell us about what to do when we can't share test collections. I mean, think about it. If these are test collections that contain stuff we can't show people, we can't show you the test collection, right? So there are going to be cases where we just can't build a test collection and share it. What do we do then? And then we'll finish up with some comments about evaluation measures. So just to get us started, this is a test collection that in some joint work with Fabrizio Sebastiani, we did, in which we were going to simulate sensitivity. So this is a test collection that you can have. And the reason you can have it is there's nothing sensitive in this test collection. This is a bunch of medical journal articles. And what we did was we went and we picked a couple of categories that would be surrogates for sensitivity. As I told you, sensitivity is sort of like a topic. And so we just cheated and said, well, it is a topic. And that topic overlaps with other topics. And so we'll just pick a couple of topics that sound to us like they're sensitive, and we can do this. I lied. This is not. Yeah. Okay. So anyhow, this is a. I think I've got the wrong reference here. Anyway, this is the collection. Gotta love it. This is a view of the collection that shows you how many sensitive documents there are per topic. So what we did was we picked two sensitivity topics, and then we picked other topics and we looked at the overlap. And the number of relevant documents, we had graded relevance here, but this is binarized. You can see varies by topic. And then the amount of sensitive content varies per topic as well. And some topics are very hard topics. They have a lot of sensitive content that has to be avoided. And other topics are not these very hard topics. They have almost no sensitive content. You can just treat them perfectly ordinarily. Okay. Anyway, sorry for the rough go there. This is work with Mahmoud Saeed. Here is a second collection that gets a little more interesting. This is an email collection. It's kind of like the Enron collection, except it's got controls over it. So the Enron collection, you can go download from the internet. This you have to order from the Linguistic Data Consortium, and you have to sign an agreement that says you understand that it contains sensitive content and that you will not quote any of it in papers. Other people can license it too, but you can't share the collection with them. So this is trying to put some sort of a policy framework around access to collections that contain sensitive content. And then we went and created annotations that actually point out where the sensitive content is in the collection and relevance to topics. And so the way we did it was we took those things that I was describing, those interviews with the archivists and the donors, and we created fake personas. These are personas in the human-computer interaction sense that help you think about design. And here we have two of them that help us think about sensitivity. And so one of them is a university professor who has some sensitivities that are highlighted here. So for example, conversations about her family and personal life are seen as sensitive by Holly Palmer, a person who does not exist. But we met several Holly Palmers who had this sort of sensitivity. And so we created this persona, Holly Palmer. And then we hired annotators and we had them read this. Pairs of annotators then tried to code as if they were Holly Palmer. And when their agreement was high enough, we turned them loose on the collection. But we have two of them. We also have John Snippert. John Snippert is an engineer. The avocado emails are from a company. So having somebody with a corporate background seemed useful. And so you can see John's concerns. And so, for example, peer reviews and collaboration on projects, those are things he thinks are sensitive. Well, that's clearly different from what Holly Palmer thinks are sensitive. And so this is the beginning of an attempt to think about what might canonical sensitivities look like. We have these two personas. And then we can do exactly the same thing. We get a set of topics. Now, these are topics that our annotators made up in the standard Trek style, where annotators learn a little bit about the collection and then they start making up topics. And so we had undergraduates as annotators, and the undergraduates are very creative and they find things about, I don't know, loans and meetings and Viagra. Well, you can imagine that the Viagra one had quite a lot of sensitive stuff in it in John Snippert's email. And the ones about loans and meetings, not so much. And so we've got 35 topics for each. There's a 5-topic overlap. And so now you can start to build systems that can tease apart the sensitive content from the relevant content. And you can get something going from this search among sensitive content, right? And we'll talk a little later on about how to build ranked retrieval systems that can protect content that's recognized as sensitive. And then the question is, how do you recognize it as sensitive? Well, obviously you train a sensitivity classifier, and there are sensitivity annotations in this collection. And so you can sort of see where that goes, right? Okay, now that's at the level of the entire document. But we also have test collections that are available for which parts of a document might be sensitive. Now, one way to do that is to think about the redaction problem that lawyers have. And so here's a particular redaction problem that lawyers have. It's called the deliberative process privilege. And this is sort of inside baseball in the lawyer's world. What they do is when people give advice to senior leaders in the US government, that advice is kept confidential. The decisions are made public, but the advice is confidential. And the reason the advice is confidential is we want people to be able to get good confidential advice. So we keep it confidential. And it's not confidential forever. It can be released after a while. It can be released after 12 years. And so we have this collection of advice that was given by people to the president of the United States in this case. And we can see years later what was considered confidential. And then we can try to build machines that can replicate that. So this is a freedom of information application. I have an example here. This is a document involving the presidential yacht. here in the United States. We don't have a presidential yacht, but we used to have a presidential yacht. And they're trying to figure out whether we should still have a presidential yacht. And on this, the president needs advice. And so he gets some advice from David Watkin. And where we got these was that these get posted on the internet after 12 years. And so you can see who it was that had the documents. This is not the person that created the documents. This is the person that had the documents. So they received them, commented on them, offered advice on them. And you might recognize some of these names. Elena Kagan is a Supreme Court justice. And so this was a very high interest case. And Cynthia Rice is a senior diplomat. And you can see the topics and all. And so all of these have these yellow markings on them, and they've all been converted to machine readable text. And you can go off and do some segmentation experiments and try to find the segments that are sensitive. Here, the segments are all paragraphs, and the segment citation down there to that collection. So those are 3 test collections that we've built over the past couple of years that will just give you the opportunity to think about what would a test collection look like, which is a little bit helpful in thinking about what does the task actually look like. Okay, Graham.
Great, thank you, Doug. Okay, so in the next part of the tutorial, we are going to move on slightly. So Doug has been telling us about some attempts to first inroads into being able to release collections publicly used to develop systems and evaluate systems that are primarily interested in handling sensitive information. But Doug highlighted a number of protocols or approaches that had to be taken in order to be able to make those very important first steps. So there's other philosophies or thoughts of how we could actually go about doing this, and this is actually acting on the data to make the data still useful, but being able to sort of hide the sensitivities in it. So we'll talk about a couple of those approaches first, K-anonymity and differential privacy. And then to finish off this section, we will look at another notion which has been tried, algorithm deposit, where you assume that you can environment where it is relatively safe to allow systems to actually act upon the data that actually has the sensitive information in it with different types of constraints than what we've spoken about already. So we'll look at these, their benefits and maybe their limitations as well. If I can get this, there we go. Okay, so slightly, I'm sure that many of you have heard of this AOL user 4417749. So quite a while ago now, I think AOL released a collection of roughly 20 million web searches that had been collected by AOL. In order to do that, they obviously were aware that there was people's information in this collection, and then they would have to do some form of anonymization so that the people couldn't be identified. So the approach that they took was to anonymize them by giving them unique user IDs. So this is the user ID for this particular user. But if you look at the text here on the right-hand side, you'll start to see some of the bits which are bolded, and some of the reasons, the patterns that could be sort of seen as to what this particular user was doing in her search history. So, for example, a query such as dogs that urinate everywhere is particularly sort of rare, it's specific. So this starts to give us an idea of some of the sort of problems that we might have to think about when we're thinking about releasing, for example, search queries or search query logs, which is what we will focus on in these first two approaches. So if you think about the types of searches that are actually submitted to search engines, as I'm sure you're all aware, there's a very large long tail of queries. And these are rather rare. So these infrequent queries can be sort of very useful pointers to specific people or characteristics of people who might issue queries such as the ones that will be found in search logs. Okay, so the AOL user, it didn't take long before a New York Times journalist managed to put together the data that was released in the AOL collection with some other external pieces of data, and very quickly managed to narrow down the sort of postcode area that the user lived in, and did some other searches, and eventually just managed to phone up the user and say, you know, this is a list of yours, and straight away the user realized that, that yes, in fact, there was her queries, and although AOL had gone to this, what they thought was an appropriate measure of anonymizing the data, in reality, there was very little protection for the people who were actually in the query log. So that's the question: how can we go about protecting the identification of people who are in these query logs, and meaning that they are not identifiable by the patterns of what they do? So, as I said, many queries are very infrequent, you know, so people might use their own name, their own address, specific strange queries that they've got interests in, or medicines, stuff like that, that are very specific to them. So the first idea that we want to look at is how can we perturb or change these bits of specific information to try and hide them. So the first approach we will look at is called K-anonymity. And what K-anonymity does, it provides a quantifiable, Doug, the slide seems to have disappeared.
Yeah, that wasn't good, was it?
No.
Hold on just a minute. I'll get
I
it
shall
back.
try and just keep talking. So basically what K-anonymity does is it tries to provide a quantifiable level of anonymity for entities. So it hides the sensitive information among K similar copies of data. So in practice, what this means is that any individual should not be distinguished or distinguishable from at least K-1 other individuals whose information has also been released. So if you think back to the previous example of the AOL user, and I said that, you know, the journalist managed to identify the sort of postcode area of the user. So let's say there's 10 people in a postcode area, then if we could narrow down the set of possible users to at least one postcode, we could say that it is a K was 10 anonymity. So as I was saying, we were going to look at in the query logs. So to satisfy K anonymity, what we want to do is just release the query click data for records appearing at least K times in the original query log. So what this does in practice, it means that you're removing infrequent queries, and that's got quite an important implication for information retrieval research, because obviously we're changing the distributions of the queries within the collection. So, you know, we are interested mainly or often in head and tail queries. But if you're removing these from the distribution, then you're potentially removing a lot of utility from the collection. But there is collections out there that use it, and recently, or relatively recently, there's the ORCUS 18 million clicked query document pairs that was released by Nick Craswell and colleagues. So as I said at the start of the tutorial, we have a reading list available on the website. So these are detailed in the reading list as well. But it has been used, and it's been shown that it can be used, but it has got limitations. Obviously, one of them is changing the distribution of the queries. But a more important, or maybe a more fundamental limitation of k-anonymity, it applies what's known as a closed world principle. So k-anonymity of all of the available data. In other words, it assumes that the data you're working on is all of the data that's available. So not only is there other data available outside presently, usually, but also there will be other future data that becomes available as well, which can be an issue as well. So these things are a limitation of the approach, and we'll come back to these later on in the tutorial, and we'll see how in practice they actually can lead to the leakage of sensitive information. Okay, so that was the first approach. Second approach we're going to briefly mention just now is differential privacy. So differential privacy, it hides terms by adding noise. So this is what I mentioned, sort of trying to disguise what's actually there without actually removing it necessarily. So it wants to add noise to the sample statistics of a data set, a collection, you know. So what it wants to do is provide a statistical proof of privacy. So, you know, you can have a certain amount of belief or confidence that the information in a data set is safe to distribute. And the main sort of overarching claim is that no additional harm should be able to come to someone them appearing in a collection that's been distributed than would have came to them, or would have been able to come to them anyway, if that same collection had been distributed without that particular person included in the collection. So in other words, to give you a sort of very general example, you know, if you have a data set which has been used to investigate whether there's a connection between smoking cigarettes and cancer, if you know, obviously we found out now, we all know that there is a connection, and that can have an impact on insurance policies and stuff. So there's a harm there where it will, you know, your insurance policy goes up, and then you know, you've got a financial cost to that. So the point there is that that harm would have happened anyway to someone, whether or not they were included in the data set or not. So harms can still come to people. It's just that anything that's specific, a specific harm that would come from a data set will not happen, supposedly, if the data set is differentially private. So here we see at the bottom just a very sort of toy example, which is from Grace Yang and colleagues. So what it does, it works on numerical values. As I said, we're primarily focusing here on query log distribution. How can we distribute anonymized query logs? And what to do is they want to sort of add noise to the sort of the numbers or the distributions, the samples of the actual queries that are included in the logs. So here we see in data set 1, we have Alice has 5 apples, Bob has 4 apples, and Carol has 2 apples. And in data set 2, Alice has 5 apples and Bob has 4 apples. Now, if the data was just released as it is there, it would be very easy to, you know, do some sort of minor computations and work out that Carol is in data set 1. So what we want to do is we add noise to the sum of the apples. So here we're keeping the same distribution, but we are masking the actual particular. And by doing that, it now becomes impossible to actually do the simple calculation to work out whether Carol is in dataset 1 or 2 or both. So in the context of IR and what's actually been used, how it's been used in this paper by Grace Yang and colleagues, what they've done is they've actually changed the sort of sample statistics on the query sessions. So instead of actually having to remove the tail end queries, they're just actually hiding the fact that these are tail end queries, Okay, so I mean, these are two approaches that can and have been shown to have sort of a certain amount of success. They have some limitations. We will come back to them sort of later on as to see, how they could possibly be applied to other approaches. But the last approach we're going to discuss in this section takes a different view on it. So instead of actually changing the sensitive information or the statistics about sensitive information in the collection, it'd be great if there was a way that we could just release the whole collection with all the sensitivities in it. Can you change slide, Doug, please? I seem to have lost control. One back. Thanks. So, yeah, sorry, as I was saying, instead of actually masking or changing the distributions of the information in the collection, it would be highly desirable if we could actually just release the collection with all the sensitivities in it and allow systems somehow to be developed using those sensitivities to actually learn from. So this has actually been tried in practice. In the TREC 2015 Total Recall track, there was a sandbox task. So in this, there was an email collection from a former governor, Tim Kaine, at the Library of Virginia. So they wanted to release the collection of data so that systems could actually access this data and learn from it. So the actual emails themselves were on site in the Library of Virginia, and there was a sandbox environment constructed so that participating teams could actually just submit their systems, run on the particular topics. So they had actual sensitive topics corresponding to sort of specific archival categories, and not a public record, open to public and restricted. And there was a particular shooting record as well. So these are, the real data, all the details and whatever, So in practice or in theory, seems like a really good idea. I'd like to encourage you just now to think of what maybe are the shortcomings or the potential limitations of this, because we'll return to it later on in the second half of the tutorial. It worked quite well. I don't know if it worked great. The results weren't necessarily amazing for all the systems, and there was people who said that they couldn't get enough access to the system, to the data, to actually make meaningful models. But as a sort of operational exercise, it worked well. The systems were submitted, and they got evaluation statistics out so they could tell how their system ran. But obviously we want to be able to try and move beyond that. So we will have a look later on about how where some of these limitations might come in. Okay, so we have talked about a few approaches of how you might begin to deal with actually distributing collections that actually have sensitive information in them. Now we will go on to look at the evaluation measures that we use for evaluating sensitivity classification and ranking strategies at the end. Okay. So where do we start? We're starting with the classification metrics. Now, I'm sure you are all very familiar with the accuracy metric. So it's a very popular metric in classification literature. It's usually applied primarily for multi-class classification in its raw sort of vanilla form. And it's basically made up of the number of correct predictions over all of the predictions, so true positives and false negatives. When we're dealing with sensitivity, however, there is a couple of issues that have to be taken into consideration. Firstly, in any collection with sensitivities, or usually certainly, sensitivity is very rare in comparison to all of the sort of normal information. You know, there's in some of the collections that we've been using, that's 1%. If 1% of the data is sensitive, then that's quite a lot. So the classes are highly unbalanced, and therefore there's well-known sort of problems with accuracy with unbalanced data. So that's our sort of first motivation to look at balanced accuracy. So balanced accuracy it's sort of the average of the accuracy for each of the individual classes in a binary classification task. And this sort of highlights the second point, why we sort of maybe start thinking about using balanced accuracy. Firstly, we're often starting with the question of, is this data sensitive or not sensitive? We can then, once we start to drill down, we can maybe start looking at more granularity, but initially all we want to know is this data sensitive? Does it need protected? Therefore, we're going to do a binary classification at first. The second point is we'll go on to talk about the context in which sensitivity classification can actually be deployed to be useful. And one of these contexts is actually assisting human reviewers who actually have the final say in whether or not something can actually get released. Now, if you're doing that in a decision support environment, so you're a decision support system where you've got automatic sensitivity classification predictions that are trying to give the user or the reviewer useful information that they can actually work with, it's really important that you're performing really well on the sensitive information. You're also performing well on the not sensitive information, because although you can be risk averse and say, right, all this is sensitive and over predict sensitivity. If you do that too much, then the users are going to lose trust in your system, and then they're going to start ignoring it basically. Okay, so we start off with accuracy measures. There's also other measures which we're very familiar with within the information retrieval community, so I won't spend too much time on these. But precision and recall are obviously very important components when we're evaluating obviously the classification performance on particular classes, or the retrieval performance when we're actually trying to build search engines. So what we usually use in classification and sometimes optimization functions is the F measure. The F measure is a parameterized harmonic mean of precision and recall. And here we see the formulation both in terms of precision and recall, the top of the slide, and in terms of true positives, false negatives, and false positives. Now, importantly, you see here there's a beta parameter. So this beta parameter is obviously allows you to sort of tune the F measure to evaluate your particular context more appropriately. And as we'll see later on, quite often this metric is tuned to be more recall oriented because there is a higher penalty from misclassifying a sensitive document as being not sensitive and accidentally releasing that into the public domain than there is from accidentally misclassifying a not sensitive document as being sensitive and giving it additional protection that it doesn't need. Okay, so I mentioned there that we are often helping human reviewers. As well as helping human reviewers, we need to learn from human reviewers too, you know. So often we will, when we're learning to actually identify the sensitivities, we have to integrate the feedback the reviewers that are actually doing the annotations. Doug mentioned that they've got passage level annotation within one of the collections. So this is what we want to do when we're trying to gather evidence about what is sensitive within a particular collection, because the sensitivities are going to vary and look very different from one collection to the next. So you quite often find yourself in situations where you're looking to be able to predict the sensitivities in a particular collection, but the historical previously judged documents that you have are not representative enough of the particular sensitivities in this collection that you're looking at. Therefore, you need to learn a sensitivity classifier very quickly, and you have to do that by using human resources, which are expensive. And so you want to be able to do it as quickly as possible. So here, we often find ourselves measuring the number of documents reviewed, or in other words, the amount of reviewer effort that it takes to learn an effective sensitivity classifier. Okay, so we've also spoken about, we started off with talking about sort of identifying sensitivities at the document level. Is the document sensitive or not as a binary classification? But Doug also mentioned how it's very important, and we will go on to look at later on, that once we know whether a document is sensitive or not, we want to know what is the sensitive information inside that document. And how do we do that? Well, we have to be able to identify the spans of text in the document that a reviewer would actually say is sensitive. So we need a measure to be able to evaluate how well we're doing, how well we're performing on this task. So here, we're just going to look at one such measure that can be deployed for this. It's by Bieferman. It's a very nice paper, and I'd advise you to go and read it if you're interested, because there's lots of sort of nice intricate details about it. But basically how it works is, so we have two segmentations, so in other words, two spans of text that we're interested in, a reference span and a hypothesis span in their terminology. So the reference span here, we would probably refer to as the ground truth or the gold standard. And here in this example now, you see that there is a passage of sensitive text within the ground truth. So here the red actually sensitive means this is the bit that is truly sensitive, and this is the bit that we want to try and identify. So we train a classifier, and we make a prediction as to which passage of text is actually sensitive. And here we see that the classifier predicts that this in the upper part of the screen is actually sensitive. So how did we get on there? How did we do? You know, is that a correct prediction? Is it an incorrect prediction? It's not a straightforward, clean-cut case, probably. You know, you see that there is some overlap. So some of the terms that we identified are probably sensitive, but some of them are not. So how do we, it depends on the context, how useful that is. Maybe if you're just wanting to draw the reviewer's attention to it, then it could be useful. So anyway, this measure goes about giving you a quantifiable measure, or a way of quantifying how well you've done in such a scenario. So it's referred to here as PD. You might also see it referenced as PK. And basically, for the two spans of text, reference and hypothesis, we have a distribution probability, a distance distribution probability, excuse me. And we've got these two sort of functions, one for ref and one for the hypothesis, where they equal 1 if the reference or hypothesis span. So if if the reference or hypothesis span match, then it's 1, else it's 0. But we have the XNOR function, which is both or neither. So in other words, what you're wanting to do is you're saying how many of these spans that you've predicted are actually inside the reference segmentation. Okay, so it's a bit of a mouthful round, but the important takeaway point here is that if you see here, there's the 4 examples, A, B, C, and D. This arrow is the same length, so you have to choose this length of how far away can the two spans be before it is either deemed a success or a miss. So here we see in A, the hypothesis and the reference are within this allocated distance, therefore it's okay. But in B, they're too far apart, therefore it's a miss. And obviously this gives us a summation over all of the spans within the document or the collection that we're looking for, and this gives us a measure of how well we've actually done overall. So I'd advise you to go and have a read through the paper, because it's actually a really nice metric. Okay, and I'll hand over back to Doug now to talk about the retrieval metrics.
Very good, thanks, Graham. So we've been doing this, excuse me, evaluation measures in 3 parts. So the first part is, as I said, did we find or not? The second one was, did we find the part of it that we were looking for that was sensitive? And the third one is, how do we now do a search, a ranked retrieval that is going to protect sensitive content? So we want some measure that tells us how well we did that. And mean average precision is not going to do it for us. So you can see here a couple of precision recall plots. And you can sit here scratching your head about what would I do to get sensitivity into this, and it's not particularly clear, right? We think of the average precision as the area under these curves. It's really the area under the peaks of the curves. The curves are very bouncy, and there's a tremendous variation across topics. But this is a typical measure that we use in information retrieval, and it's not going to help us very much here when we have sensitive content. And so instead, oops, okay, we lost it again. So instead, what I would suggest that we do is look at discounted cumulative gain. And so just as a quick review for discounted cumulative gain, we give lots of credit when something is highly relevant, a little bit of credit when it's moderately relevant. You get no credit at all if it's not relevant, but you showed it. And you get no credit at all if you don't show it. So how could we extend that to think about protecting sensitive content? Well, fairly straightforwardly, we can say that if it's not sensitive and it's highly relevant, you get a lot of credit. If it's moderately relevant, you get some credit. If it's not relevant, you get no credit. There's no difference there. And if you don't show it, you don't get any credit at all. There's no difference there. The one difference is if it's sensitive, then you get some penalty. How much the penalty should be depends upon the task. We'll talk about that a little bit later on with a specific example. But you can see here an example where we give more of a penalty for finding something sensitive than we give credit for finding something highly relevant. Now, there's a discount factor in the relevance, and you could apply a discount factor to the sensitivity if you thought that showing the user sensitive content in rank 3 was better than showing it in rank 1. But you might very well think that showing sensitive content in rank 3 is awful in the first place, and it's just as bad as showing it in rank 1. So you don't have to discount the sensitivity in the same way that you discount the relevance. And so you can construct a DC, or a cost-sensitive discounted cumulative gain measure that gives both positive and negative credit. Now, there's a problem when you do this, which is that if you normalize, then you're normalizing something that has not only negative values, but unbounded negative values. You could find any number of sensitive documents, and here you get no discount rate, so you could get any negative value. And of course, there could be topics that have large numbers of positive values. And so the normalization that we normally do for this is going to behave in unexpected ways because DCG was not originally designed for negative values. And so it's easier to reason about this measure with unnormalized values, but you can, of course, normalize them and use it as an objective function. So there's work that still needs to be done to design optimal objective functions for training. But this measure is not bad for looking at what's happening, and we'll use it as sort of a diagnostic probe for how systems that are trying to do ranked retrieval that protect against showing sensitive content are doing at that. If they get negative scores on balance, they're doing badly. If they're getting positive scores on balance, they're doing well, better than not doing the search in the first place. And so we can use this as a way of beginning to get an understanding of how these systems are behaving. Alrighty, so that brings us to what we euphemistically call 3:20 p.m. We'll run a little ahead and a little behind here. That's fine. We've got some padding in the schedule to allow for that. I want to stop at this point and ask for questions. We've been talking so far about background and evaluation, and we're going to go on next and talk about detecting sensitive content. But if there are any issues in the evaluation or indeed in the background that people want to talk about, this would be a good time.
I have a question.
Mm-hmm.
Sorry, so in this variant of, let's say, discounted cumulative gain, we are making the hypothesis that, let's say, relevance is non-binary. Is it sometimes necessary to postulate the sensitivity is non-binary too, sometimes?
Oh, absolutely. You could think about sensitivity if you really wanted a complex model. Sensitivity depends upon who the searcher is, and sensitivity depends upon when the searcher is searching, and sensitivity depends on why the searcher is searching. So you might have something that's a little bit sensitive under some circumstances. The sensitivity would be different if somebody else was searching, or the sensitivity would be different if they searched at a different time. So we couldn't model the decay of sensitivity if we just had to think about sensitivity as binary. And so this is at most illustrative of a class of evaluation models that could be built. Other questions?
Hitarth, you can open your mic and speak.
Can you hear me?
Yes.
Yeah.
All right. Yeah. Thanks, Graham and Doug, for the great presentation so far. So I have one question. Just continuing from what you just said. Like the also can be sensitive depending on when the searcher is searching it. So do you think differential privacy methods can be used for or like as a potential solution for these time-based sensitivities to create like different sets of data sets based on the information which is sensitive for a particular time period?
Yeah, I mean, certainly I mean, the interesting thing about time in relation to sensitivity is, as Doug was alluding to, is that sensitivities can decay.
Just
Do you
go
mind?
ahead. I'll mute.
Okay, thanks. So sensitivity can decay over time, or can on occasions actually things that weren't sensitive before could become sensitive. So, I mean, that's a very tricky situation to model, to protect. And I would, differential privacy might get you so far, but we will actually be looking at this problem in much more detail later on in the tutorial. And as part of my breakout room at the end, that's exactly the question sort of asking, it's like, in relation to sort of data that could become available sort of later on, how can we go about actually protecting against this? So, whether different itself related to time specific or sensitivities over time, I'm not convinced that it would be enough to actually deal with the problem. I mean, we've highlighted some of the sort of limitations of these approaches already, and I think the time issue is a very open question, which we will be. So if you come and join our breakout group later on, then maybe we'll be able to get into that question in much more detail.
Yeah, I think Graham is right that modeling it is really complex. But if you took very long timescales and you said, I'm going to take, I don't know, the sensitivity around Hillary Clinton's email, and I'm going to take it 100 years from now. I think 100 years from now, you wouldn't need differential privacy to protect the content, and now you do. And so it seems reasonable to me that 10 years from now, we might not need to fuzz it up quite as much as we need to fuzz it up today, because the consequences of revealing some of the information might be much lower. And so differential privacy is epsilon secure, and you could adjust epsilon over time. But we, as Graham says, we have no way of thinking about how do I map my fuzzy concept of privacy to this setting that I'm going to use. And so I do think there's work to be done on that question.
Thanks for that. Looking forward to the breakout session.
Good.
Okay. Any last questions? We'll go on now to.
I have one.
Yeah. Yes.
Possible. It's more of a comment than a question. Actually, you mentioned the F beta as a function, to bring in cost sensitivity in evaluation. My comment is that I've never really liked the beta, F beta, as a way to model, cost sensitivity, because my impression is that, the user has got no idea what value of the beta parameter he or she would enforce, So suppose that, you want, in a sense, your false negatives are much more costly than the false positives, What value of beta are you going to use? Are you going to use 2 or 3? 3 or 3.5? 5 or 6, To me, beta is not an explicit way of modeling cost sensitivity. Conversely, my impression is that, a measure where you impose a unit misclassification cost in your contingency table is an explicit way to model this. Because you say, well, to me, a false negative, say, predicting that the document is not sensitive, and while it should indeed be sensitive, has a cost of $50, while the other opposite mistake has just a cost of $2, you know. That's, you know, a user does have a sense of what the costs are. But beta is just a parameter which is not very explicit, not very conspicuous, not very understandable to the end user, who is the one who should have the last word on costs, what the relative costs are.
So I'll talk later on about a paper that Fabrizio Sebastiani wrote, in which he used the F measure as a cost, and then I'll talk about another one in which he used explicit cost measures as a cost. And I'll try to bear in mind to point out the problem with both approaches.
Okay, thank you.
Okay, very good. Thank you, Fabrizio. That's the actual paper with Fabrizio Sebastiani, which we will get to. But let's go on. So this is a great way to do it, to have a little bit of conversation at the end of each of these sections. So please do ask questions, and you can type them into chat if you want to. The next section is going to be done by Graham, who's going to talk to us about detecting sensitive content, and maybe we'll pick up the pace just a little bit here with the idea of making it to the breakout time.
Yeah. Okay, great. Thank you, Doug, and thanks everyone for your questions. Okay, so yeah, let's move on. So we have mentioned briefly already that if we can't detect the sensitive information, then it's really difficult for us to do anything. It has to be the first stage, it has to be robust, and we have to have some level of confidence in the approaches that we're developing, or we have to be able to give the custodians of the data some level of confidence that, you know, the claims that we're making are, you know, justifiable. So that's the sort of theme that we'll be sort of looking at throughout this section. Firstly, we will read it, and then we'll look at features a wee bit, and then we'll actually look at some specific sort of case studies of how we've actually gone about developing sensitivity classification systems. They can actually have been used in practice. Okay, so let's start by looking at features. So today, all the interest and all the hype seems to be focused on neural network models, end-to-end models, where you just train a system, and you quite often hear it said that, you know, we don't have to engineer features, we just let the model do it ourselves, you know. In reality, what they are doing usually is they are using features, textual features, but the model's figuring it out themselves. However, with sensitive information, different types of terms might be interesting, might be more important, might be useful to know particular characteristics about them. So here we've got an email. If we're going to start to look at this email and say, right, is it like or not, where would we look? Firstly, who's the email from? Here we see the email is from Hillary Clinton. And it's replying to an email from Melanie Verrier. So first question is, we know who Hillary Clinton is, but it would be nice if the algorithm actually had some indication of who Hillary Clinton was as well. So maybe we want to tag Clinton with some sort of additional knowledge so that that can be integrated into the classifier. But we also want to know who this Melanie Verrier is, or Verrier. So, secondly, when was the email sent? Here we see it's on Saturday at 9:41 p.m. What does that tell us? Does it say anything interesting? Well, it's meant to be a business email. Why is a business email sent at 9:40 on a Saturday night? We'll see later on that you know, sensitivities often in business accounts and such often appear at the weekend. So I mean, maybe that could be an indicator as to say it's a flag. Maybe we should look at this in a wee bit more detail. Okay, so what do we know so far? We know that we have Hillary Clinton and Verrier who is actually an ambassador. She was an advisor to Clinton actually at the time. So we've got important people, some activity happening at a strange time. What else do we know? We're thinking, right, Saturday night, why would you be emailing on a Saturday night? Either you're just catching up on emails, or it's something that's really important. You're reacting to it on a Saturday night because you have to react now, or it's just mundane, it's routine. Here we see that there's 50 hours in between the original message being sent and the reply. So it can't be that important that she's replying really quickly or so. Your husband, we can work out who it's from, who it's to, therefore whose husband we're talking about. Is Hillary Clinton's husband? Oh, her husband's the president of the United States. Maybe that's interesting. And who's this person, Schwab? So it turns out it's Klaus Schwab, who was also, he was involved in the transactions that were going on at the time. But putting all this together, we can say that it's just replying to an email. There's nothing specific in it that we need to flag. But enabling the classifier to know that could be really important, or it could be really useful. So the point is, there's lots of different things. We've spoken quite a bit already about the fact that who's sending things, when they're sending things. All these different features are important for us to understand whether or not something's likely to be sensitive. So it can be words, it can be times, it could be the identities of senders, recipients, etc. The interactions, if it's the burstiness of emails. Here we see on the top right hand of the screen, there's a plot that's sort of showing the fraction of the emails that are sent over a particular period of time that are actually sensitive. And if you notice this peak here on the start of the weekend, it's, of all the emails sent at the weekend, most of them are sensitive. If you think about it, then, that seems reasonable. It's business emails. You shouldn't be sending much at the weekend. If you're going to send it at the weekend, then there should be a reason for doing it, unless you're just catching up your emails. So anyway, there's lots and lots of different types of information that we could be using to better help classifiers identify sensitive information. So what we're going to go on and do now is look at a couple of case studies where, we're not yet using all of this information a lot of the times. We use some interesting little approaches, but primarily what we're just looking at is the distributions of features, of term features within the documents. So how did this come about? So for the last 5 or 6 years or so, myself and University of Glasgow colleagues in University of Glasgow have been working firstly with the National Archives. We're now part of a consortium of companies who are delivering the first large-scale digital sensitivity review system within the UK government. But way back sort of 4 or 5 years, 6 years ago, the National Archives realized there was going to be a problem. They said, in the UK, there is laws that state that government documents must be transferred to the public archive for public access within a certain amount of time. If you don't manage to achieve this without a really good reason, then you're breaking the law. They realized there were so many documents, digital documents, that were going to have to be reviewed. There was absolutely no way that the current practices you would be able to do it. So we need to develop these systems to be able to maintain transparent, open government, so there's access to the documents. Once the documents go to the National Archives, they are then governed by the Freedom of Information Act. The Freedom of Information Act has 14 categorical exemptions, which apply to historical records. So this is what Doug was mentioning right at the start of the talk in the background, and the fact that categorical exemptions are broadly defined. They don't say this particular thing is sensitive, but that particular thing is not. They give you vague notions, such as if this information would be likely to damage the relations of the UK and another country, then it should be withheld for a certain amount of time until the sensitivity decays and it is no longer likely to be sensitive. How do we go about finding out whether or not information is likely to damage the relations of the UK with other countries? It's a very, very challenging problem. So that's what we're going to look at just now. So when we teamed up with the National Archives, first thing we had to do was develop a test collection so that we could actually work on this problem and learn what these sensitivities are actually like. So we got a test collection of 3,800 government documents, and what we did was we got expert sensitivity reviewers to actually sensitivity review these documents and provide sentence level or passage level annotations to highlight the exact sensitivities and the text that's sensitive within all of the documents or each of the documents. And what they did was they reviewed it for 2 of the Freedom of Information exemptions. Section 27, which is international relations, the one that we've been highlighting so far. You don't want to damage the international relations of the UK. And the second one is personal information. Now, personal information is again a categorical category in this context. So it's not, you know, dates of birth and you know, structured information like that necessarily. It can be very, very loosely defined, context dependent. You know, if someone's making accusations, for instance, about criminality or something like that, things that aren't proven. So again, there's this context dependent scenario that we need to be able to model within the problem. Okay, so this is just a sort of summing up what I said. So previously, before you go to review a collection, we don't know which of the text is likely to be sensitive. So when you come to a collection that you're going to review to be passed to the archives, you can't assume that you know what the sensitivities look like in that collection. You have to learn it as soon as you start looking at the collection. And it's all context dependent. Who said it, where, when it was said and stuff. What sort of things are likely to fall into these categories? Well, information which has been supplied with a reasonable expectation of confidentiality. So for instance, if you have, you've got embassies all around the world, say one of these embassies is in a war zone or in a dictatorship who's oppressing their citizens, and you have someone coming to a diplomat or the embassy, you know, telling the embassy what's going on and providing an account of the bad things that are happening in that country. That record would be taken at the embassy. It would then be sent back to central government, where it stays in central government so that they can use the information. But after the period of time, currently 20 years, there is a legal obligation for that document to be released to the public archive. So this is different from what Doug was saying earlier on in America. In the UK and certain other countries, there is an obligation to release. So the expectation is that all information will be released. Therefore, that's why we have these exemptions. You can't release all the information unless you can accurately and robustly identify the sensitive information and protect that information. If the informant information was released, it could put them and their family at great danger, you know, because you shouldn't be years, you know. So what else is there? Disparaging or inappropriate remarks about important people. You don't want to insult important people in this case in other countries. Allegations, things that aren't proven, negative remarks about the capabilities, and also personal information. So as I said, it can be very sort of broad, it's context dependent. So things like employment history and stuff like that. So if you think about an organization, the director of a company, for instance, their details might be in the public domain and that might be expected, but lower level employees, chances are their information is going to be viewed as their own personal information. So even the role that a person plays within a company can have an influence on whether or not information relating to them is sensitive. Okay, so this is just, we've sort of rammed this home quite a bit so far, but who said or did what, when, about, or for whom is the kind of structure that we're looking to start to think about whether or not a particular passage of text is likely to be sensitive or not. And we want to be able to build models that can look at collections of data and start to identify patterns where, patterns that fall into these sort of structures or categories can be indicators of personal information, or sorry, of sensitive information. But it's really highly context dependent. So how can we do that? So language models have become extremely popular and have been shown to work in lots and lots of different tasks in the information retrieval community over the last 4 years or so, maybe a bit longer. And importantly, this sort of started off with the word embeddings and stuff like that. We've now got all these context dependent embeddings and stuff, but the main point is that within these embedding spaces, the positions of words can encode a lot of meaning or semantics about how the relations between the words are, so that's the sort of thing that we're looking to do, to be able to give this information to the classifier so that the classifier can start to look at the statistics of it over the entire collection and pick out the relations that are likely to be indicators of sensitivity. So as you'll notice from the citation at the bottom, this is from a 2017 paper. We were using word embeddings at the time. It was shown to work particularly well. What we did was we take the one-hot encoding representation of the document, we concatenate it with the dense semantic representation of the document, and then comparing that against a sort of text classification baseline, we get significant improvements. Nowadays, in our current project, we have started looking at sort of contextualized embeddings, and we're getting some really interesting results. Well, interesting. But I would encourage you, we've spoken about some collections already that are publicly available now. Unfortunately, our collection obviously cannot be released publicly because we have to work on the real raw sensitivities to be able to give the governments enough confidence in the solutions that we're actually developing. But you can go away now and you can take BERT or one of these contextualized models and go and run it on one of the available collections and see how well you do, see if we're actually going to be making improvements on the same task, So that's our sort of basic first approach to try and identify or develop a classifier that can automatically classify these context-dependent sensitivities. So the second sort of case study that we're going to think about is, as we said, whenever we go to a new collection, the sensitivities in that collection are most likely new, and we haven't seen enough historical examples of them to be able to know that we can definitely apply our pre-trained classifiers to this collection and get the results that we're expecting to get. So how do we go about quickly learning a new classifier without using a lot of reviewing resources? One approach is active learning strategies. So there's a lot of active learning literature, and basically what it does is it has a function which decides which documents should be chosen to be reviewed next. Quite often the document that the classifier is least sure about. So it's by getting a label, documents that the classifier is least sure about, that's thought to give the classifier most useful information to improve it more quickly. Key here is we want to do this with a technique that allows us to learn a classifier, an effective classifier, using the least amount of reviewing effort possible for a number of reasons. Obviously, the reviewing time is really expensive, but also the reviewers themselves have ways that they want to review the documents. Having, for instance, they might want to review documents chronologically because looking at the sequence of events might tell the reviewer a lot about whether or not a particular piece of information is sensitive. So they want to be in control of how they review, but we want to be able to learn to classify sensitivity quickly. So in this work, what we did was we thought, well, how can we see if we can improve or learn this more quickly? And as we said all along, it's really important for us to know what the particular sensitivities are within the documents. So what we did was we have the reviewer annotate the sensitive text within the document. And what we're wanting to do is use that as a feedback to the classifier, so the classifier can integrate it into the actual active learning model, so that it can use this information to make better decisions about which documents should be reviewed, to identify what sensitivity looks like in a particular collection. Okay, so what we do is we get the reviewer to annotate these sensitive passages of text, and then we have some function. In this case, we use high information gain of particular terms to say, out of all these terms that they've actually annotated, they're not all as useful as each other. So let's try and identify out of the annotations which are the most important terms that are going to be useful for the classifier. We integrate this with the evidence that we're actually getting from the collection itself, and we use that amalgamated evidence to train the classifier. So the question is, can a sort of partnership between the automated classification approach and the reviewer perform better than just the automated approach by itself? And I'm sure you will have guessed that yes, we found that it did really help in this situation. So I'll talk you through this plot quite quickly. So on the left-hand side here, you see three curves. They're labeled entropy, margin, and utility. Now, these are the three active learning strategies that we use to actually prioritize the documents for review. In the right-hand plot, you see that we've extended these strategies with the high information gain term features that we've extracted from sensitivity annotations. And what we're wanting to do, if you look on the x-axis, you see it's the reviewer effort that we're interested in. So, excuse me. So in the left-hand plot here, what we're looking to see is how quickly can we learn an effective classifier. In this case, we're saying 0.7 balanced accuracy is as effective as we're getting on this collection. So that's, how much more quickly can we reach an effectiveness of 0.7 balanced accuracy if we use the reviewer's feedback as well. And here, instead of 1,600 documents to be able to reach 0.7 balanced accuracy, we actually managed to do it after just 800 documents. So the takeaway message here is, combining the efforts of the automatic approach with the human reviewers' knowledge and insights into the sensitivity enables us to build up a picture of what the sensitive information within a particular collection looks like much more quickly than we would be able to do it just with the automated approach. Okay, so if you notice on the last plot, it reaches a peak. On the right-hand side, it's about 800, after 800 documents, and then it starts to reduce. So that fact, along with the fact that I mentioned, that reviewers have their own priorities. They might want, for example, to review documents in chronological order because that tells them something about the sensitivities. It's also really important that we actually learn when to stop the active learning process and when to switch back to just assisting the reviewer with a normal classification strategy. So this plot just shows an experiment that we did to start to investigate this. And so far, we've just looked at sort of heuristic approaches. So I've listed the sort of the stopping strategy, as we call it. So we want to know when to stop the active learning process so that we can switch back to a normal process. So here we've looked at 5 heuristic strategies about how we might start to sort of guess or measure when we should, when we can stop the process. So firstly, I'll talk about the blue processes first. These are processes from the literature. So stable predictions, class change, and min error. So these sort of heuristic approaches, they stop the active learning approach. Firstly, stable change when the classifier's predictions stabilize, i.e. there's a level of agreement between the predictions that the classifier makes on subsequent iterations of the active learning cycle. So in the interest of time, I didn't go into the actual active learning process as much as I maybe usually would, but it's an iterative cycle whereby the reviewer is presented with K documents at a time, and the reviewed K documents, the classifier is then retrained, and the expectation is that the classifier will get better with each bunch of K documents that it's presented with. So the first stopping strategy, stable prediction, says that there's these predictions are going to stabilize over time. Second one, class change, just means that the classifier won't switch its predictions between sensitive and non-sensitive as much. So once it stops sort of when it's less sure about documents. The third one is minimum error. So it's like when it stops making so many classification errors. These are just ways that we can look at how the classifier is performing and say, right, well, based on this notion of how it's doing, maybe we'll stop. The ones that we developed ourselves is total confidence, which basically looks at the actual active learning function itself and the confidences that it is, i.e. like maybe a prediction probability. And so when that stops increasing, we say, right, it's learned as much as it possibly can. And for least confident, it's the same, but it's on it's only the documents that it is least confident about. Long explanations, but basically what we're going to say is that in this plot, the grey sort of jagged line is obviously the effectiveness of the classifier, and right in the very right-hand side, we've got this green dotted line, which is the oracle approach. So this is an approach that knows what the optimum classifier is. So we want to get as close to that green line as possible along the x-axis. So here you see we've made some inroads compared to the approaches from the literature, but we are literally just scratching the surface on this, and it's a really sort of open and interesting problem that needs to be addressed for classifiers to be used effectively to assist human reviewers. Okay, so how are we doing for time? Because I was kind of rattling through that a wee bit. So
we've got about 10 minutes until the break.
Right, okay, so I will be very quick with this and we'll get to the end of this section by the break. Okay, so we have spoken about assisting human reviewers, and that's the aim, that's what we're wanting to do. So we have done some work to actually look at it. So this is the evaluation system we've done. Basically what we want to do is we want to reduce the amount of time that the reviewer has to spend reviewing documents in order to be able to learn the sensitivity classifier. But once we've got a classifier, we want to assist the reviewer in making their sensitivity judgment. So that's the part that we're looking at in this experiment. We want to say, now that we've got a classifier, can we use the classifier to provide the user with useful information that allows them to review documents more quickly while maintaining high levels of reviewing accuracy. So it's a basic sort of active learning setup, and we are monitoring what the impact of the reviewer is. Our primary concern is their reviewing speed. So how do we measure that? We use this metric called normalized processing speed. And basically what it does is it provides us an average reviewing time over all of the reviewers. But it normalizes for two important points. Firstly, all reviewers will have different reading speeds naturally. So you want to average that out over all of the reviewers, and also different document lengths will have an impact on how the reviewers address the problem and also the time taken to review. So the basic calculation is the doc length over this exponent of log time and the two mu's, which are explained there. And it's basically just a geometric averaging approach to give you a words per minute measure of reviewing time normalized over the other reviewers. Okay, so how did we get on? Basically, what we've done here, or for both approaches, but we did a classification user study where we evaluated 3 treatments. The first treatment, none, is where the reviewers are not provided with any classification predictions at all. So this is just their normal reviewing environment. We gave them 2 classification treatments. The first one, back 0.7, is a classifier that is 0.7, which is the same effectiveness as we've seen in our previous experiments. We want to know, is this good enough? Is it useful enough, this level of effectiveness, to actually help the reviewers? Can it improve their speed while they maintain their accuracy? And that's what this plot is showing us here. We've got speed in the left-hand side, the normalized processing speed, and we see that a balanced 0.7 actually increases the reviewing speed from about 150 words per minute all the way up to 260 words per minute. So it's, in terms of speed, it's shown to be very useful. Does it enable them to keep their to do this while maintaining accuracy? And basically, this is just the right-hand plot saying, you know, when we actually looked at their results and compared it a known ground truth where different reviewers had actually reviewed these documents also, the level of agreement basically, or the accuracy between the reviewer and the ground truth was actually increased also. So it sort of shows that providing reviewers with automatic sensitivity classifier predictions can really help the reviewers to perform their sensitivity reviewing task, which is good because it means we'll be able to the public and maintain the sort of open government philosophy. However, it's worth noting that not all classification predictions are the same, and not all classification predictions will help the reviewer the same amount. So if you think about it, you've got sort of 2 variables and 4 different possible outcomes. A document is either sensitive or it's not sensitive according to, or not sensitive according to the classifier. So you've got 4 different outcomes. Either the reviewer thinks the document is sensitive and so does the classifier, the reviewer is not sensitive, and so on. And each of these different outcomes have a different impact on the amount of assistance that you can actually give to the reviewer. So if the reviewer and the classifier both think the document is sensitive, we're actually getting a 60 words per, or sorry, a 50 words per minute increase in reviewing speeds over all the reviewers. So that's brilliant. However, obviously, if they disagree, it's not so obvious that it's going to actually help them become faster. If it's here, we see if the reviewer says that the document is sensitive, but the classifier says it's no sensitive, then we actually slow the reviewer down slightly, and because they have to then think about it for a second. But you know, they are the ultimate judge, so they're going to say yes, it's sensitive anyway, and we're going to go and continue, stick with my prediction. However, if you notice down the bottom of the screen, if the reviewer says that it's not sensitive and the classifier says it is sensitive, then that means that the reviewer has then got to go and search for the sensitivities in the document that the classifier is telling them that it exists, and they can't see it. So in practice, we can actually slow them down on this particular outcome, you know. So although we've improved the review speed overall, it is worth looking in future as to when we should actually show a reviewer a particular sensitivity prediction. What's the likely impact of that prediction? And Doug will actually go and talk about something similar in the next part of the tutorial. So I think we actually got time for a few questions before the break. So if there's anything that wasn't clear in that, please ask questions, because I was very aware of time and I was trying to not eat into Doug's time too much. Any questions in WOVA?
I don't see any questions in WOVA, although I'm not a WOVA expert. And I don't see any questions in the chat, but we have plenty of people who are here live and in person. You can just unmute and ask a question.
I would like to ask a question. So I may have missed some bit of your the last part of your presentation, but let's say that your basic conclusion is that using a TAR process, you know, has a positive influence on both the speed and the accuracy of reviewers by sensitivity, you know. Okay, so I can, that's fairly intuitive for speed. I don't see how it, I mean, it's not terribly intuitive for accuracy. How do you explain that using TAR, that supporting a sensitivity reviewer by TAR increases their accuracy?
Yeah, I mean, it's a very good point, and it's a good insight. And the terminology is maybe slightly confusing, because at the end of the day, the reviewer is the ultimate arbiter of whether or not it is sensitive. In practical situations, often you've got one reviewer, one review is either sensitive or not. In our experiments, what we had to do was we had to compare against the ground truth. Now, we didn't go into this in any ways thinking we can improve the reviewer's accuracy by providing them sensitive predictions. But what we have to be sure about is that we're not reducing their accuracy by you know, just making them go faster, but the level of the thoroughness or the accuracy of their review is reducing. So in reality, you know, what we're actually saying there is that the level of agreement between reviewers increased, because you know, in the experiment we're looking at almost the reviewer as a classifier, because they're making the classification judgments. They're either correct or they're incorrect, and we can evaluate this, and because we've got a ground truth, and we can, you know, we can measure it with the usual sort of classification metrics. In practice, you're looking at a consensus. Once you have multiple reviewers reviewing the same piece of same document or the same piece of information, you can see, is there a consensus that this piece of information is likely to be sensitive? Because there is no absolute right and wrong one answer, So in practice, all we're really doing is improving the agreement between a set of reviewers. Now, I could actually, go on to say why that might be the case, but I mean, we haven't done enough. We haven't been able to investigate enough to know precisely why that is the case. But there's obviously a supervised model is trained on the sensitivity annotations of a reviewer or a set of reviewers, and their beliefs are obviously encoded into that ground truth. So there is a chance that by learning from that data, you are influencing other reviewers. That may or may not be the case, but the main thing is you don't want to influence them in the wrong direction. You want to make sure that if there is any particular sort of influence, then it's a positive influence, and that's really all we were sort of trying to show with the accuracy of the reviewer there. So
let me just break in and note that we've reached the break time, and that coffee is available and cookies in your own kitchen, and we'll continue here with formal conversation. There's WOVA's got some kind of a place you can go and have some kind of conversation too. But be back here, please, at 45 past the hour. And we're going to pick up with the next phase of this, which is protecting the sensitive content that's been detected. So I didn't want to cut that off, but I do want to make sure people know that you should get up and stretch and go out and do calisthenics and get coffee and whatever you want, and we'll see you back at 45 after. There was a second question, I think, for Graham. There were two people asking at once before.
Yeah, I had a question, but I think it's partly answered like in the previous question itself, and it's a bit more general. So I mean, I'll be happy to take it in the breakout rooms, but just to put it here, so we technology assisted review is quite common in solutions like e-discovery toolkits, for example, legal systems. So how different or rather how difficult is the sensitivity review task, like technology assisted sensitivity review, than general task for technology assisted review? Like apart from the classifier itself, because I think the classifier is the key here, but like apart from the classification, what are the like more challenges in a sensitivity review framework as compared to a general TAR task?
I think so. The majority of sort of technology assisted review TAR tasks, the literature is to do with e-discovery, and so Doug will be able to say more after I sort of say my wee bit. But basically, the majority of the active learning approaches in the e-discovery sort of literature are looking at the first sort of part of the this finding documents that are responsive, i.e. relevant. But that isn't actually the part of the e-discovery task which is most closely aligned with sensitivity. The part of e-discovery that's most closely aligned with sensitivity is this notion of privilege. So in e-discovery, they're applying the technology assisted review to find documents that should be released. So the structure of the technology assisted review, the framework of it underlying the starting point, is very similar, but what it's actually applied to do, so we talked about how we sort of build on that by integrating the reviewer feedback to try and map it to the sensitivity task to sort of build a picture of what the sensitivities look like, so that instead of just trying to find relevant documents, we're actually trying to sort of find the actual sensitivities in the collection, But as far as privilege goes, that's the stuff that should not be released, and so that's analogous to sensitivity. And I know Doug is going to talk about that in a wee bit sort of later on. But I mean, I don't know if you would agree, Doug, that the TAR approaches, the majority of the TAR approaches in the literature, as they're applied to e-discovery, are more in connection with responsiveness as opposed to privilege.
Well, certainly there's been much more published on responsiveness, or what we would call an IR relevance. But the privilege literature, TAR is being more and more applied to privilege. Let me see if I can speak a little bit to the differences. So it's very different from responsiveness, right? For responsiveness, what we do in TAR, in e-discovery, is we hire freshly minted lawyers to do essentially low-paid review work, about $1 a document sort of scale for review work. And that is based on essentially a rubric that's provided for what's on topic. And we're doing a lot of inter-annotator agreement, and we're doing it at very broad scale, right? We have lots of content. When we do privilege review, we're doing it at smaller scale. We're doing it with more highly experienced and more expensive annotators. And we're doing it against something that's considerably more judgmental. It's harder to write down the rubric on privilege review. And so the difference is in sort of the complexity of the task between relevance or responsiveness review and privilege review. Now, if you think about what's different between privilege review and sensitivity review, in privilege review, there are two things going on. Now, I'm not a lawyer, but some of my friends are lawyers. One is that you're trying to find things that are actually privileged. And the second is you're trying to come up with a legal strategy with regard to what you might reasonably claim as privilege. So privilege isn't, an absolute fact, it's a judgment, and you could debate it. And some privilege judgments may be more favorable to your client, and some may be less favorable to your client. And so when you're doing privilege review, you have as is the case also in relevance review, but it's more direct in privilege review because of who's doing the review. You have both strategic thoughts and sort of practical thoughts at the same time that you have to build in your mind this rubric for what you think is privileged. It's a little bit different for the sensitivity review in that you don't have an adversary. So you don't have that you have to keep, but you do have a different problem. So in privilege review, each document is privileged or not individually. But in sensitivity review, some documents are sensitive in combination with other documents. And so you have to sort of anticipate what other documents might already have been released or might be released in the future when you make a decision about whether this document can be released, right? And this is a problem, this general area is called the Mosaic Theory, that I can put pieces of information together and build a mosaic that paints a picture that no one piece of information paints. And that doesn't exist, to my understanding, in privilege review, because in privilege review, it's the circumstances of the communication in attorney-client privilege, or the circumstances of the work in attorney work product, or confidentiality of trade secrets, or whatever privilege you're seeking to claim. Those are all individualized on the document. That's the way the legal regime has been developed. And the legal regime develops differently in sensitivity review in the government context, because Mosaic Theory that says that I'm not trying to protect the words in the document. I'm trying to protect the knowledge of the fact, right? And the knowledge of the fact could be established through inference from words in many documents, right? And this is a problem we don't have a good handle around technically for what to do about it. But I think privilege review is the right thing to compare to, and I think this idea that privilege review is atomic to the document, but that it has some strategic element to it, are the two things that differentiate it. And that may not affect the technology at all, as Graham says, at least at our present level of technology.
Mm-hmm.
Hitarth, is that useful?
No, that's quite useful actually. I mean, I never looked actually privilege review and sensitive review. It's so different if talking in this way. Yeah, I mean, those are like very good pointers to be.
Yeah, but I think your general intuition that you can simply apply a TAR system to the problem, and one TAR system is much like another TAR system in that they're operating at the same level of technology, and they're not really designed with this distinction in mind. TAR doesn't know about the strategy, and TAR doesn't know about the Mosaic Theory.
True.
The current TAR technology. We actually do have to get TAR technology that knows something about the Mosaic Theory, but we don't have that now.
Okay.
But we might have after our breakout rooms at the end of the tutorial.
That's one of the breakout rooms, is the Mosaic Theory.
Okay. Anyone else, or Darth, any more questions, or anyone else?
Not for now.
Okay, good. If there's not, then I might stretch my legs for 5 minutes.
Let's take a break. I'm just going to turn up my volume in case anybody comes along and wants to chat.
Perfect. Good.
Good. And thanks, Graham. I think it's going very well.
Yeah, thanks. That's good.
Okay, I have a Zoom recording.
Very good.
Am I?
One minute. All righty, welcome back. We're going to go ahead and get started now with protecting sensitive content. And so as you can see, we're essentially building in this process towards the most challenging of the issues, which Graham will get to handle, the things we don't know completely how to do. But we've made some progress on protecting sensitive content, and so I want to talk about that next. I'm going to break this up into 3 pieces. One is to talk about end user search. And so the issue here is that we want people, can somebody please mute Raphael? Thank you. We want people to be able to issue a query and see results, and issue another query, see results, and do an interactive search process while the system is keeping them from seeing sensitive content. This is perhaps the most challenging task, and we can see how well we do at it. Then we're going to fall back, and we're going to look at the Freedom of Information Act setting, not using FOIA, but using e-discovery, where we send over the transom a question. People can actually who are trying to answer the question can actually see the sensitive content and remove sensitive content, and then send back an answer. So their search is done by someone else, and there is a longer latency to it, so you can't iterate on the search, but there you can get higher confidence that you have protected the content. The third thing is we're going to look at what can we do now for redaction, for actual protection of content within documents. And so these are the three issues we're going to talk about. Again, happy to take questions as we go, or at the end, or in the chat. And so I want to start with essentially the two basic pictures. We're going to be thinking in terms of ranked retrieval all the way through. And so this pre-filter approach is the approach used in Freedom of Information, FOI, in the UK, or Freedom of Information Act, FOIA. People say FOIA in the United States. And the documents come in. We somehow filter them for sensitivity, including with people in the loop. And then having filtered them for sensitivity, we can then search and do, well, here we'll do ranked retrieval. The alternative is you could search, this is the second one we're going to talk about, and you could then filter the search results. And this is more efficient if the filtering is an expensive process, because the search, of course, can be better automated and can be done with perhaps less skilled labor. And so you can either pre-filter or post-filter. And those are fairly obviously the two approaches, but they're not the only two approaches, because the sensitivity classifier knows things that aren't used in these models. So in particular, what it knows is it knows the distribution of probability of sensitivity. So we show the sensitivity classifier a document, and it says it has a probability of being sensitive that's 0.96. And we call that sensitive. And then we get another document, it says 0.90, and we call that sensitive, right? So if we have this binary sensitive or not, we're not using all the information that the classifier knows about how likely this document is to be sensitive. And so the third thing we might do is we might give the output of the sensitivity classifier, not the decision, but the probabilities to the ranker. Or we could give features to the ranker that the ranker could use directly. And so if we do that, then we have the opportunity to learn to rank, right? Now, if you want to do learning to rank here, you need to have some objective function, and the objective function needs to balance sensitivity and relevance. So if you had such an objective function, as we did from the earlier conversation, then you could use a list-wise learning to rank approach to directly optimize that. And so we'll show you some results using ADA rank. And so here's how I want to look at the results. I want to look at that measure I defined for you earlier, cost-sensitive discounted cumulative gain, with a cutoff at 10. And where you should put the cutoff is an interesting question. If you put the cutoff lower, you have a higher chance of getting sensitive documents, deeper. If you put the cutoff shallower, you have a lower chance of getting sensitive documents, but also a lower chance of getting relevant documents. So you could, of course, cut off at 0, and that would protect all the sensitive documents. And so there's a judgment call on where you put this. But here for the results, I'm going to show you reader cutoff at 10. As I say, if we cut off at 5, we'll do better on sensitivity protection and less well on finding relevant documents. And here I've got a horizontal bar at a cost of 0. Things below this cost are dominated by the sensitivity cost, and things above this are dominated by the relevance benefit, right? So benefit up, cost down. The cost and benefit are being subtracted in exactly the form that I showed you earlier. So 5 points off every time we get a negative value, and every time we get a sensitive document, and 3 points gain for a relevant document, but then discounted, and the sensitive document's not discounted. Now, if we pay no attention to sensitivity at all, if we just do a relevance-based search, many topics have no sensitive content. This is in that collection I showed you earlier that is simulated with, it's built on OHSUMed collection. And you can see that about half of the topics, so these are topics sorted by decreasing score, about half of the topics have positive scores, and about half of the topics have negative scores. And so this is sort of the 50-50 condition is what you get for free. And you want to do better than 50-50. You'd like to have no topics that get negative scores. Now, if we do pre-filtering, so now we're paying attention, moved all the sensitivity things with a binary classifier, we can do better. If we do post-filtering, we do about the same as you would expect. It doesn't matter whether you pre-filter or post-filter. And if we then do the joint model that I showed you, this green line, we can do even better. A number to pay attention to is where it crosses zero, because when it crosses zero, if we've set the costs correctly for good and bad, for relevance and sensitive, to reflect our actual application, then the percent of the queries or topics on which we're doing badly is the thing to look at. And here I've got the percents on which we're doing well. So originally what I had called 50% is actually 56% if you count carefully. And the green line, the joint model, is out at 79%. And it's a small improvement over what you can get with pre-filtering or post-filtering, but you shouldn't sneeze at small improvements. We need, yeah, good. And so this is with a sensitivity classifier that's not terribly accurate. It's only an F1 measure of 0.75. So that's something like a 0.75 precision and a 0.75 recall. And so this is a promising result that you can get 79% by doing this joint model, or you can get 75% or so just for showing up for work and doing pre-filtering or post-filtering. Now you can actually do better than that. So there's the 79%. That's the best we did on the joint model. The green was the joint model. And that's exactly the same line. The light green line here is the same line. This is Mahmoud Saeed's work. Mahmoud is with us here on the call if you want to ask him about it. And the extra step is to do diversity ranking. So in diversity ranking, what we do is we take the results and we cluster them. And we select the most relevant item from every cluster, and we present that as a cluster exemplar. But here, we're not after relevance, we're actually after creating sensitivity. So if we cluster them, this is clustered by topic, and then we select the least sensitive thing according to the sensitivity classifier, then what you would expect is that the relevance would go down and the sensitivity would go up, would also go down. It would be better, right? You'd have less trouble with sensitivity. And you can see that here. So if you look at these whisker plot, this histogram is telling you how well we do after clustering when we substitute the least sensitive document in the cluster for that document. And you can see here that we almost never make our situation better by relevance. But when we start to get out here where we were having trouble, we actually do recover from the trouble and show relevant documents that are not sensitive in some cases. And in fact, we move from 79% to 89% of the queries have non-negative results. Now, notice some of these non-negative results are zero, but nonetheless, non-negative results for 89% of the cases. So this is sort of an extra trick where you trade away relevance and you get sensitivity. If you go back and you evaluate this with normalized cost-sensitive discounted cumulative gain, on average, this is a loss. You don't get an improvement here. But what you do get an improvement on is the number of queries or number of topics that reveal sensitive content. And of course, that's what can get you in trouble. Okay, so that's the first part of the story, is doing sensitivity aware ranked retrieval. We can actually do it. And we have to think about what the measure is and how the measure should be designed, and what we should actually be looking at after we've optimized to the measure. Do we want to just look at the measure, or do we want to look at some ancillary measures like the number of topics, for which we're able to do better than 0? There are 106 topics there, I think. Okay. The next thing we might do is intermediated search. Let's say you say that's not good enough. Right, that might be good enough for parental control. You know, if a child and their parent negotiate and agree on what the child's allowed to see. Well, if it ever fails, you know, you could use it that way. We need to mute the new arrival. And so you might want to do better than that, and to do better than that, you're going to have to get a human in the loop. And we're going to get a human in the loop in exactly the way Graham said. But Graham said what we were going to do was we're going to review the documents for sensitivity. And here what we're going to do is review them for relevance first and then for sensitivity, because relevance review is cheaper than sensitivity review. And so this motivation comes from the lawyers. And lawyers are great fun to hang out with because they have the real problems. So this is a paper that I promised you I would mention by Fabrizio, in which Fabrizio worked with the group at Glasgow and on their sensitivity problem, on their collection, and applied a technique like the one I'm going to show you, but to optimize the F measure, really? Okay, anyway, to optimize the F measure. Now what we're going to do is we're going to try to optimize a cost function. And we're not going to do it just for sensitivity review, but for relevance review first and then sensitivity review. So it's going to be a two-stage process. We're going to first find out if it's relevant and then find out if it's sensitive. Lawyers say privileged. Lawyers have a legal concept of privilege, which is a kind of sensitivity. And so we're going to use privilege here as the sensitivity we're after. And when lawyers say privilege, they actually mean several different privileges, but we're just going to use this concept of privilege generally to talk about it here. There are three possible outcomes here. One is that the lawyers could give to the other side the documents they had asked for. So the other side has given a topical specification. The lawyers have reviewed them, found that they meet the topical specification and that they're not privileged, so we'll give them to you. Or we find that they meet your topical specification, your relevant specification, but they're privileged, but we're going to tell you they exist in case you want to litigate whether or not we're correctly claiming privilege, right? So we have to reveal them. So we put them on a privilege log and we give you the privilege log that tells you about their existence. Or if they're not relevant at all, it doesn't matter if they're privileged. We never have to review it for privilege. The not relevant documents we don't have to give. Okay, so it's a three-stage process. And the basic idea that Fabrizio brought to this was that there are two basic ways you could do this. Anytime you have a finite population, you can actually look at all the documents. This is what Graham was doing. And so if you have more effort, your search will be better. And eventually you'll have seen everything. And your search will be as good as it can. It won't be perfect because people aren't perfect, but it will be as good as it's ever going to get. Or you could do less effort and build an automatic classifier, and it would be maybe better for the amount of effort you put in than doing manual review with that amount of time. But then you're going to have to live with that classifier because it can't do any better than itself. It's as good as it's going to be. It's not human. It's not perfect. And it's probably less good than the people are. And the whole idea that Fabrizio and a couple of his co-authors had come up with is let's just start there and make it better, right? So let's start with what the automatic classifier can do, and let's spend our time on the most likely errors. Well, of course, if the automatic classifier knew which the errors were, it wouldn't make the errors. So you have to think through the structure of the problem. And here's the structure of the problem. You build classifiers for relevance and for privilege at the beginning. And so now I know for every document, not whether or not it's privileged or whether or not it's relevant. I know the probability of relevance and the probability of privilege, right? And then what we do is we take those probabilities and we use it to prioritize which documents to show. And the documents that we show are the ones that are most likely to get us in trouble. You know, there are two kinds of mistakes we make, right? We show something we shouldn't, or we can not show something we should. And one of those is worse than the other. And as Fabrizio says, nobody can figure out with the F measure what that stuff means, but we could figure that out with cost functions. And so that's what we're going to do. And then we do a second review after the relevance review for privilege, after we know which documents need to be looked at. Now, we make an assumption here that the humans that are doing the review are perfect. It's just a simplifying assumption. You could take that out in your future work that cites ours if you want to. So here's how the cost function is set up. I want to just focus on this number 600 here. So you were supposed to give the document. You claimed it was privileged, and it's not, right? So if your prediction is you should, vice versa, the correct decision was it is privileged and you should keep it and log it, but you produced it. Big problem, $600 problem. Every time you do that, you just get $600, you pay $600 in monopoly money to the other side. I mean, this is bad. Now, how do we know that that's a $600 problem? Well, we give lawyers questionnaires and we have them fill out questionnaires like this, and they put in numbers like that, and they say this is 4 times worse than that. And if they answer enough of those questions, we can figure out what the relative costs are, right? Okay, there's a $600 problem. Now, dirty little secret here. The second $600 problem might not cost $600. It might cost $1,500, and the next one might be $8,000. So this might not be linear, but we make the simplifying assumption that it's linear. Now, how many mistakes are we going to make? Well, remember, we have probabilities, and the probabilities don't tell us which ones are wrong, but they tell us how likely we are to be wrong. And so we can calculate the expected number of mistakes. So we think we're going to make 100 mistakes. Well, 600 times 100 is, do the math, 60,000. And if you do the math on all the others and add up all the costs, the total cost is only about 62,000. And most of the cost comes from this one kind of mistake. So this kind of mistake is going to be the mistake that gets our attention. But a different lawyer with a different case would give us a different cost matrix, and a different classifier trained on different data would give us different numbers of mistakes. And so you could do this for all sorts of different problems, right? Anyway, the other thing you have to know is how much does it cost to review a document? Well, for relevance, it costs in reality about $1. US dollar to review a document. And for privilege, it costs something on the order of $5. The reviewers are pretty fast, but the privileged reviewers are more highly trained, and they're doing a more complex process. And so now what you want to do is you want to review them until it's not worth $1 to do the next review because the potential savings is less than $1, right? And for privilege, you review them until the potential savings is less than $5, and it costs $5 to do the next review, and you should stop at this point. You don't have to stop. We just rank ordering them in the order in which you should review them. But if our probabilities are right, this is where we think you should stop. So we can put a little green arrow there and say, you know, we think about here, you can stop, right? Now, of course, will people really stop, or will they look at them all? Well, if they look at them all, then it didn't matter what order they looked at them in. And so this assumes that they're willing to let some things go based on automatic classification where there's high confidence and low risk. And we evaluated this using a Reuters collection. So it's very similar to the collection that I confusingly said earlier was with Fabrizio, which wasn't. So this was a Reuters a news story collection, and we picked a topic that was going to be a relevance topic, and then we picked 5 privilege topics that overlapped someplace between 1% and 20% with that relevance topic. And then we just went off and built the system. This is the work of PhD student Jyoti Vinjamur. The results here I'll summarize as saying whatever the total cost was, we'll just call that 0. That's the cost of this approach, and we can ask what would have been the approach, what would have been the cost if we'd done this fully automatically, right? And this is for the cost function, and the answer is you would have paid 29% more, right? However much it costs to do this process, 29% more if you do it fully automatically, and that's because of risk. Or you could have done it fully manually and just looked at every document, and that would have cost 235% more, and that's not because of risk. There's no risk left at that point. That's because of work. That's how much work you have to do. Something in between with active learning, using uncertainty sampling or relevance sampling, and it costs about 50% more if you do that. So it's actually better not to do active learning and just do the fully automatic thing, but it's even better if you do this cost-sensitive ranking. Okay, so this is two-stage cost-sensitive ranking. And what you need is you need the people on the other side to believe that your system is doing something useful, because if they don't believe it, they're going to pay the 235%, and that's what we're trying. Alrighty, those are the first two parts. Here's the third part. Now I've got a bunch of documents that are sensitive. I can't just say, sorry, you don't get to see them. I have to then say, let's remove the sensitive bits, and you can see the rest. And you're probably thinking that we're going to do it like this, just like the CIA with their black magic markers highlighting, right? Well, we don't have to do it like this. We can do it like this on the bottom. So here's an example. It says the patient suffers from AIDS because of a blood transfusion. He was diagnosed when his immune system responded poorly to influenza. Now, if we replace that with the black magic marker business, it's really hard to figure out what's going on. But we could equally well replace it with something like this. The patient suffers from a long-term condition. Well, AIDS is a long-term condition, but lots of other things are too, right? Arthritis is, for example, because of a medical procedure. Well, that's not a blood transfusion necessarily. So we're fuzzing it up, but we're fuzzing it up in a way that is still correct. It's just less specific. So the distinction here is between redaction on the one hand and sanitization on the other hand, where we just fuzz it up. Well, now you might fuzz it up wrong, in which case you really confuse people, right? So if we had apple and we fuzz it up to fruit and it was about the company, that'd be like really bad, be misleading. Be better to just draw a black line over that, right? But if you fuzz it up correctly, you could support understanding. And so the question is, can you recognize what you should fuzz up? And then you can separately decide whether you want to just cover it up or whether you actually want to try to fuzz it up in this sanitization way. Now, there are a lot of people that have worked on this problem. And one way to think about it is something called T-closeness. And in T-closeness, what you do is you ask the question, well, how many different words could body refer to? Now, body here refers to immune system. So body could refer to immune system or finger or eyeball or, I mean, all kinds of other things. And so as long as it's 10-way ambiguous, you could say, oh, body was, yeah, sure, that eliminated the problem. Even you're just sort of asking how many other documents could there have been that get fuzzed up the same way? This is sort of like Graham's K anonymity, right? Anyway, that process is called T-closeness. But that doesn't have anything to do with how likely each of these things would have been to be in this position. So if you want to know how likely it is to have it in this position, you want to go to some information theoretic measure, and a natural measure to go to is information gain, right? So information gain is minus the log of the probability in some corpus of the term, right? So we've got this term C. We're trying to protect AIDS here, or HIV is actually what we're going to try to protect. And we're going to try to protect it in the Wikipedia page for HIV. We're going to try to get all the words out that tell you what this Wikipedia page is actually about. And still let you see something in the Wikipedia page. And so we've got the information content of that word, right? How rare is that word, essentially, is what we're doing here, minus log the probability. And then we can ask for some other word like immune system. How associated is immune system with AIDS? Again, in some large collection. Here in this work that I've got from Sanchez and Bate, they used the Bing search engine and how many documents were returned for the word. But you could use any way of doing this. We'd use the Google Ngram corpus for this these days, for example. This is 2016 work. And you could find out how associated each word is. And then what you would do is you would find the set of terms, not just words, terms, multi-word expressions too, that are associated with some fraction of the information content of the concept you're trying to protect, which in this case is HIV, the human immunodeficiency virus. And so that concept is called point-wise mutual information. And you're going to go to the amount that is the point-wise mutual information divided by some degree of protection you want, which is going to be alpha greater than or equal to 1. And so here are some results that they have. We just look at the redaction results. And this will tell you how much of your document remains there after you say, I want to protect it. I'm sorry, how much of your document got removed. So if I want to protect it fully on the HIV page, I have to remove almost every word, right? So I remove 96%. But if I, nope, sorry. I get to keep 96% of the words. If I want to protect it at a higher level, at this double level, so alpha is 2, so I'm protecting against half of it, I get only 17.6% left. So high protection kills a lot of the document. But then we can do sanitization instead. And if we did the sanitization well, and this is just a simulation study, so it knows nothing about word sense ambiguity and things like that, the upper bound on what we could keep in terms of mutual information is about 61%. Right? And so this idea that we can do sanitization is a way of thinking about the problem, and the using point-wise mutual information is a way of thinking about the problem. All kinds of details left to be worked out, but it's helpful to have at least some way of thinking about it. Okay, but that's not the only thing we could do. I've been talking about having a document and trying to show you all but a little bit. Take out the important, the really sensitive bits. But you could do it the other way. You could say, well, I have this email which I got in response to my question about museums. So I'm searching Don Knuth's email about museums. And this is on the actual open web. This is EPAD, this Stanford University Libraries thing that I showed you. And what you do, you tell them, I want Don Knuth's email and I want to search for museums. And it finds you mentions of museums. And it shows you the name of the museum. And it shows you every other named entity in that message. And it shows you the position of every character in the message, so you see how big the message is. And you can see who the message is from. This is Don Knuth's secretary. Don Knuth never sent an email in his life. And you can see who it was sent to, not the full email address, but you can see the beginning. And you can see what the salutation was. It was 4 letters followed by 1 space, followed by a letter, followed by a comma. And so you can kind of get a sense for this, and you can do this few searches and get a sense for whether they have emails you want to see. And then you can get in an airplane and fly to California, not today, but after the pandemic is over. And you can certify yourself as a researcher and use the collection and see the actual emails. And this is how you know if you want to fly to California, right? So it doesn't answer your question. It answers your question about whether there's an answer to your question. And so you don't have to think about this redaction as if we're trying to take things out. You could think about the redaction as, well, which things should we put in? Which things are safe? And then the rest of it will just ... Of course, I know something about how long words are and what people tend to say in salutations. That looks like dear space H. I'm guessing that's dear space and some letter. And so you can actually infer content here. And so you have to think about this, but you could show this to a donor and say, this is the thing we're going to show on the public web. Don, is this okay? And Don could go back and say yes or no, right? This you can understand. Okay. So we don't know everything about protecting sensitive content, but we know enough to see the question. And I'm happy to take questions if there are any. And now we have something in the chat.
There was actually a question in the chat for you. So for the two-stage retrieval privilege work 2018 paper, how is topic overlap defined?
Okay, so we have the writer's collection, and for the writer's collection, we know which documents are relevant to which topics. So I pick a topic, and it's going to be a relevance topic, and then I want to pick a sensitivity topic. So let's say that the topic that I picked is, I don't know, industrial accidents or something. I don't think but it's a financial thing. But anyway, let's say we get industrial accidents, and then I go pick a sensitivity topic, and this is just a simulation, right? And in the sensitivity topic, something that has some relevant documents in common with industrial accidents. So maybe I'll pick something about, let's see, mechanical engineering. And so mechanical engineering overlaps 6%. And so that's in my 1 to 20% range. And so I'll pick that. But I probably won't pick something that involves financial vehicles. I don't know, SPACs and things like that people are talking about these days. Should I invest in a SPAC? Because that has nothing to do with industrial accidents, and nothing that's relevant to SPACs is going to overlap with industrial accidents. And it just wouldn't be worth our while to try to figure out if we can protect the sensitive content if there isn't any. So we model the sensitive content as something that has an overlap with whatever we picked as the relevant content between 1 and 20%.
So just to ask a question one other way, yes, thank you, Doug.
Sure.
So the percentage overlap of relevance has to do with the set of assessed documents across topics. Is that correct?
That's right. That's right. It's
Okay.
so-called positive overlap, right? It's
Okay.
not kappa, it's not chance corrected. It's just a matter of how many of these documents, how many documents in this category are also in that category.
Okay, thank you very much. And then, as you mentioned, it sounds like the topic selection is a manual. It means a thoughtful, but it's a manual process, correct?
No, it's, well, what we do is we just go and we make all of the topics that have some degree of, we find all the topics that have some degree of overlap and select 5 of them. So it's a stratified sample among the set.
Okay. Thank you very much.
So we pick the relevance topic first, and then we pick the so-called privilege topic. It's not really privilege. But the problem is that the real privilege test collections are privileged.
Yeah. So
We actually can't have them. And so once we publish this, then somebody else can take our software and they can go off and run it on their thing. And they can either come back to us and smile, or they can come back to us and frown. And if they smile, then we think it works in reality. That's sort of the same problem Graham has when he works with the government.
Okay. I had one other quick question, but I'll defer it in case anybody else wants to ask anything, or if you need to roll along. So
We have 32 seconds left. Who's got a question? Richard, you get to ask your second question.
So about the point-wise mutual information stuff, that was very interesting. One thing that I wasn't sure about when I looked at the results, so I got the idea that we're trying to find words that have a, ideally you're trying to avoid the terms that have a low coincidence with certain other terms, because that would signify, information. But you showed single terms that were used to evaluate in the simulation. And I was trying to figure out if that's after redaction of all terms related at a point-wise mutual information above a certain threshold, or just the single term and its associated items. So for example, homosexuality.
Yeah.
Was it just terms that have a high point-wise mutual information with homosexuality in a collection, or does this sort of propagate out? You know what I mean? So is it one term that we're trying to eliminate, or is it everything with certain?
So we're eliminating several terms, but it's not transitive.
Not transitive.
That's right. So we find the terms with high point-wise mutual information with homosexuality, and we remove those, but we don't remove the terms that have high point-wise mutual information with those.
Okay. So it is term specific. Okay.
it's specific to the target term. And one of the problems here is you have to figure out that that's the term that needs to be protected.
Right.
Right?
Yeah,
Because nothing here told you which term to protect. So in this work, what they did was they picked Wikipedia pages on potentially sensitive topics.
Okay.
And then they tried to protect what Wikipedia page it was.
Okay.
Right? And as a technical approach to explore this, that's a brilliant idea. But you couldn't then take this and bottle it and give it to the CIA and expect them to use it.
Right.
Because knowing which thing to protect is the art.
Could IDF with some filtering provide reasonable candidates to make the process easier, or?
Yeah, so Graham's work, he's got a bunch of terms that his people pick. So he's got two things going on. He's got the active learning learns, how to weight the terms. And he's also got these people saying, yeah, and if it says Donald Trump, be careful, right?
Right. Okay.
I don't think that was actually one of the examples at the time, but.
Yeah, I apologize. By the way, I missed the daylight savings time note, so that's.
Quite all right, you're the only one.
Okay.
Yeah.
The tutorial actually became much more popular an hour later.
Yeah.
That's when Wowa told us to be there. That's why.
Very good. Okay, I think we're out of time for questions, but thank you for the questions. And the next thing that's going to happen is that Graham will entertain us by telling us what we don't know.
Yeah, thanks, Doug. So yeah, this section of the tutorial is really just highlight a few still pretty open questions, things that we've not addressed so far. So far we've been looking at, what's the core problem? How can we go about addressing the core problem that we're interested in as information retrieval researchers, and solving the problems that are out there for the practitioners that we're aiming to assist at the moment. But there's actually a huge sort of field of potential things that we would need to try and address if we were to really try and solve this problem from a holistic sort of point of view. So we're just going to mention a few of these quickly. I'm not going to go into them in any great depth. We're just here to spark your interest and get you to start sort of thinking about them a bit, hopefully. So what's the first one we're going to look at? Encrypted search. So this is private information retrieval, it's known as in the field. And there's quite a bit of work on this already, to be honest, but it's certainly some interesting questions still surrounding it. We're going to look at mosaicing, and we're going to look at algorithm deposit leakage. Okay, so first, let's see if I can get this slide to move. Okay, so private information retrieval. So what's the basic problem here? We want to create an environment where we can protect the confidentiality of documents and queries. So we're protecting the information from an outside intruder. So the diagram here shows you a sort of a basic sort of outline of what we would like to be able, or we can do. This has obviously been done already, but what we're wanting is an encrypted representation of the document collection, and the constructs that we need to build a reliable search engine, so term dictionaries, etc. And this is going to be stored in a secure data center, but the data center itself isn't necessarily trusted. It's an untrusted data center, say. So this is why we're wanting to make sure that we hide all the information that we can, and we're wanting to ensure that nothing is the information is not actually leaked out to users. So here, down the bottom of the picture, we have Olivia. Olivia is a content owner, and so she's owning content, but she's also allowing Alice to search the content. But if you remember, we said that we've got an encrypted version of the documents and the search engine structures within this data center. So that means that we also have to have encrypted queries as well, so that we can do the matching between queries and documents on the encrypted data. So this is quite a sophisticated step into, you know, a view of how we might sort of start to make a completely secure environment to deal with information. You know, there are some issues with it. I mean, I'll encourage you to sort of go and read the literature to sort of get a further understanding of it. You know, obviously, things like the search results effectiveness can be sort of reduced and whatever. But the main point of sort of highlighting this and discussing it is to sort of leave you with a sort of more broader, high-level theoretical question, and the fact that, you know, this is based on the notion of encryption, and, you know, encryption has a sort of lifespan almost, you know. So certainly things that used to be well encrypted, we can now understand pretty easily. And, you know, this notion will only sort of potentially get, you know, this process will speed up as our approaches, technologies speed up as well, you know. So the big question is, you know, like, what's the next steps for private information retrieval and encrypted search? You know, we can see that it's a good solution for things at the moment, and within certain sort of boundaries, we can have a reasonable degree of it working, you know. But, you know, what's the limitations, and how do we get over them? So that's like a sort of open question looking forward. And, you know, if you've got any thoughts or suggestions, please, or questions, put them in the chat as we go. Okay, so that's the first thing we wanted to sort of look at, was private information retrieval and an encrypted search. The second one that we will look at, if I can get the slides to move. Here we go, is algorithm deposit leakage. So we've already looked very early on in the tutorial, actually now, this morning, at an algorithm deposit scenario where in the TREC 2015 track, there was sensitive information from an email collection that was put within a sandbox environment, so that systems could be passed into that environment and act upon the data, and only some summary statistics could be let out. It worked within that context, and it's an area of research where you know, there's a lot of interest in. For instance, in the project that we are working on in the moment within the UK government, we have to go in behind the firewall to actually deploy systems on their data and train their data, and we have to go through lots of clearances to get stuff out of the firewall, you know, because we can't, you know, information leakage is something that's really important. So given this little example here, and only allowing you to remove summary statistics from sandbox and algorithm environment, I'd like you to sort of think for a second about how you might be able to pass out the nuclear code just by using normal relevant summary statistics, for instance, mean average precision, that we would use routinely. So hopefully, you know, it's quite obvious because it's such a simple diagram. But the point is here that, you know, even with these really sort of hopefully quite tight constraints that you're trying to build into the sandbox environment, anyone who's coming into this environment and building a system, that system is getting put into an environment which has got access to all of the sensitive information. That person who's building the system can build whatever they want into that system, and they can do whatever they want. You don't really know what it's sort of doing necessarily. So what they could do is they could just say, right, well, we'll pretend that we're doing your information retrieval task, and what we're actually going to do is we're going to go and we're going to search for the nuclear code, and oh, we've managed to find it. Here we go. So all we do is we just send the statistical analysis that has been agreed with the authorities that they're allowed to send, in this case, mean average precision, and just that one summary statistic, they can actually communicate the sensitive information which is in the collection. So, I mean, this is a simple sort of illustrative example to sort of raise the question in your mind. You know, it's like, how do you really go about securing systems like this? You know, just now we have to work on a basis of trust. So you limit the access to the sandbox environment to only parties that you trust. Is there a way that we can get beyond that with technologies, or has technology sort of reached the limit and you can only sort of do it by imposing additional constraints on the problem, which is, you know, what we have to do working within the UK government, you know? Okay, so algorithm leakage deposit, that's another thing to sort of go and think about. You know, if you're wanting to protect sensitive information, you have to be able to have a good understanding of all of the places within your system, even if you think that's a secure system, that it could potentially leak, you know, without you knowing it. Okay, so I sneaked this one just at the end because there's been a lot of interest sort of building up recently in the literature relating to sort of BERT-like models, sort of commonly known as these Sesame Street-based models. And, you know, the main concern with these models is mostly to do with like commercial sensitivities, but it's also, there's starting to be more and more sort of chat about actual sensitive sort of demographic information and stuff like that being able to be leaked as well. So I'll tell you how. I was hoping to give you a bit of time to sort of think about it, but the main process is, you know, like Google and these people, you know, they've been really good to the community by releasing these big, huge pre-trained contextual language models that lots of other smaller businesses that don't have the resources to build. So what they do is they take this pre-trained language models and they do a wee bit of fine tuning on the top of the publicly available language model to build their own commercially sensitive model, which is probably most likely trained on collections which has sensitive information in that data, with the expectation that it's within a secure environment and it's not going anywhere. However, all an adversary has to actually do, because the large contextual model is already in the public domain, it takes very little effort to actually just send queries to the proprietary model to get answers to the questions, to start to build up a relatively small test collection. That test collection can then be used to fine-tune the publicly available BERT model to come up with pretty much the exact same model as is used by the proprietary vendor, you know. So this example here is the reference that I've given here is a nice inroad into the problem, but there is other interesting papers that are starting to look at, you know, having done this and effectively stolen this model that's been trained by a company, you can then go and look into it and then start to probe that model that you've learned to find out what the distributions of protected characteristics are within the model, you know. So it's an interesting question going forward, and is that, you know, this new sort of paradigm that we're going into, as our processes and our approaches to different problems change, they bring more risks and more security risks with them, you know. So our approaches, our thoughts of how we actually address the holistic nature of sensitive information retrieval is going to have to keep evolving and improving. Okay, so that was Sesame Street-based retrieval, and finally in this section I'm going to go on and talk about the mosaicing problem a wee bit. Now we've spoken about this and mentioned it a few times already, and there's been a discussion over the chat, and this sets us up nicely because actually I'll be looking at this in one of my breakout room afterwards. So what is mosaicing? Basically, it's this notion that you've got multiple sources of information, and by putting together snippets or chunks of information from these multiple sources, you can infer some piece of information that doesn't actually exist in any of the individual sources of information. And that information that you infer could potentially be sensitive. So here we see this document, the history of the custody and deployment of nuclear weapons. So this, as it states in the title, was a sort of record, I think between 1945 and 1977 of where nuclear armaments were, or American nuclear armaments were sort of stored around the world. And this was released after a Freedom of Information Act request sort of many years later. Now what they did while they were trying to protect the sensitive information in. So Doug has mentioned obviously some of the characteristics of redaction and maybe some of the limitations, but here, if you look at the right-hand side of the slide and you start from the top and you start to read the place names, we've got Guam at the top and then Hawaii, and then we've got a couple blacked out, and then we've got Johnson Island. You can start to think of, so what's the differences between these things that are blacked out and the bits that are not blacked out? So some are in America, some are not. So you start to think about, you know, what these redactions might actually be. More importantly, we've spoken a number of times already about the fact that it's so difficult to be able to know what information will become available in the future and how to protect against that. So that's a clear issue that needs to be thought about within the mosaicing challenge. So at the time, maybe there wasn't enough evidence available to really know what these things were that were blacked out. But then other resources come along, say for instance, Wikipedia, which has lists of countries, and you know all of the countries in alphabetical order, and you can do a very sort of easy sort of systematic look through this list to say, right, countries could be there. We know that they're not American, and it's somewhere between H and J, which leaves I. So already you're reducing the, you know, we talked about this notion of k-anonymity, you're reducing the size of your pool of potential candidate places. So it's outside America, it starts with a particular letter. Sorry, I'm having difficulty getting it to go. And, you know, put one thing together with the other, and here you can quickly derive that Iceland was one of the places that were blacked out. So here we have, you know, the fact that Iceland is supposedly a non-nuclear country. If America was shown to be storing nuclear weapons in Iceland, it's going to be a really massive diplomatic sensitivity, because it's going to sort of break the agreements or conventions that exist between these countries, and it could, have really serious potential consequences. So having done this inferences and whatever, they've reached the conclusion that it's Iceland that is storing the nuclear weapons. And, Doug might want to tell us a wee bit more about the details of the story in the chat, but my understanding is that it turned out that it wasn't actually Iceland that was storing the nuclear weapons, but the risk of people thinking that it was Iceland was enough to make the Americans say who it actually was that was blacked out. So the fact was that, by doing inference, you didn't actually quite get to what the sensitivity was, but they got close enough to make enough of trouble for America that America was willing to sort of break its silence, stand in and risk the consequences by actually saying, no, this is actually what it, So it's a really serious problem, and it's a really challenging problem, and we will be looking at that in the next breakout room, or my breakout room. Okay, so that was a quick run through of some of the other issues that we might want to think about, future issues, things that might be not so well defined in the future. Okay, so I think at this stage I shall hand back to Doug, because he's the first one to explain.
Okay, so we have one question in the chat, which is from Richard again. And Richard asks the question, with this homomorphic encryption that you spoke about, are people searching directly into the encrypted documents using the encrypted queries? Or does the search engine see the documents, but we only use encryption going back and forth between the searcher and the search engine?
Well, the goal is that the information is not released to the search engine itself either. So we have encryption of the actual documents and of the sort of secure, the indices and stuff are secured as well. So it is an encrypted representation which is sent to the data center, and the query itself is encrypted, and the matching is done at the encryption level. So I don't know if that answers your question, or if Doug wants to add anything to it, but
that was it. I was just curious whether people were looking at having these collections in the search engines themselves that are already encrypted, and then searching within that using homomorphic techniques. It sounds like the answer is yes. Thank you.
Very good. Are there other questions? Okay, we're about half hour from the end of time, and we want to preserve some time for the breakout room. So let me suggest that we tell you what the breakout rooms are now. While I'm doing this, maybe Graham can be opening the breakout rooms, or the organizers can open 2 breakout rooms for us. And then we can, we'll do a quick wrap up while people are picking their breakout room, and then we'll disappear into the breakout rooms. And when the breakout rooms are done, we'll just disappear into the ether. And so there are 2 breakout rooms. And for each of the breakout rooms, we have a logo, and we have, so sort of a team mascot, and we have what we're going to be talking about. And so my breakout room is going to be designing a clay track, a clay lab, that's going to be called the SH track. All right. So if you think back to Ashley Madison, we are going to try to build a system that's going to do relevance and sensitivity and find the evaluation framework for that. So we're not focused on the system, we're focused on the evaluation framework. And so if you're a clay person, you want to come hang out with my team. And here's what we're going to do. We're going to pick the task. and then we're going to pick the evaluation framework. And all this is going to be done interactively. This is not me talking. This is us discussing. And when we're done, we can actually go start a clay task if we actually want to do that. And Graham.
Thank you. So similarly, it's going to be an interactive session. It's not going to be sort of me talking. And the general idea is, we've mentioned this mosaicing problem quite a few times today. It's a challenging problem, and we're wanting to start to think about how can we start to investigate building solutions to address this problem. So the overriding sort of thought is, how can we build an experimentation framework that can actually build systems for identifying mosaicing challenges and evaluating against them. So the starting point of this will be sort of, what's the motivating research questions? What sort of granularity do we want to look at this at? I mean, there's different inroads into trying to solve the problem. So we'll spend a few minutes sort of, discussing that. You come up with ideas and whatever, and then we'll settle on one of those contexts, and we'll start to try and say, right now, within this context, what do we actually have at our disposal, and what would we need to do to be able to start to build a framework that we can start to investigate the problem.
Okay, great. And so before we disappear into our breakout rooms, mine will be room 1, Graham's will be room 2. You guys can just select yourself to a breakout room. If you have any trouble, you can send a note in chat, and the organizers of the conference will zap you to a breakout room, because Graham and I will already be gone. But before we disappear on you, let's do our final comments. And so one of the things I wanted to mention here at the end is that this is not a technical question. The reason we need the technology is because of a policy concern, that people are concerned about sensitive content. That's a policy problem. It's not a technology problem. Once we understand the policy, there are things that technology can do to help. But technology does not solve the complete problem. Technology makes possible new solutions. But that doesn't mean that technology shouldn't be or should be used in isolation. Technology is always used in the context of policy. And so we should think about what policy protections we need around the technology for its limitations. As Graham told you, algorithm deposit is not perfect. We can signal information out, but we can use policies to protect against nefarious behavior. So for example, we could say you can only run 2 systems. Then you can't get all those digits out that Graham got out. Or we could say you have to be accredited as a researcher in order to submit your systems. And so if you're the Library of Virginia, you say not everybody can run a system. If you run a government transparency office, well, maybe you shouldn't be trying to pull information out of our system. But if you're information, then yes, you can. Of course, this creates all kinds of problems too that will have to be sorted out, but this is what people are good at, is designing policies to protect sensitive information. We've been doing that for a long time. So we're still in the early days. And most of the work that we've shown you hasn't been neural work because it's been done in the early days. And so despite our disparaging references to all those kids that are things that look at words, build things that look at words, and then build things that look at other things, and build new stuff. And there's lots of stuff to do here. But don't stop at text. Text is really a surrogate for what I think is the real problem. What I think is the real problem is speech. That's where the killer app is here. And so eventually we're going to need to make friends with people who do speech recognition, who do speaker identification, who do diarization, who do all those things that exist in the speech world. And we're going to have to think about those as well. And I guess the last point is, we constantly build lousy systems and then measure how lousy they are. We very rarely build perfect systems and then measure the fact that they're perfect. And the entire history of information retrieval research is people getting good results out of lousy systems. So once they do that, we work hard to make less lousy systems. And that's going to be the same thing here to be useful. But in this case, we have to be fairly good to be useful. And so it's going to take us some time, I think, to build really good systems and then to develop confidence on the part of the users in terms of how good they are and how to build the policy protections around those. Right.
Good. Okay, so my closing thoughts are, following on from Doug's comments, how do we, as a community, see how we can sort of move on from here? We've made good inroads so far in dealing with the sort of initial technical problems, but it's much, much bigger than that. The advances that we've got so far, we have done working with governments, with lawyers, with people who have particular challenges and for some reason a real need to get this fixed now or yesterday. So the first 2 points here are sort of related to that. Who else should we be talking with? In other words, what sort of channels of communication need to be opened up? These things can we actually define, and which parts can we actually tackle with technical solutions? And sort of following on from that, we need to know who else we need to be working with, So, we've been talking about cryptography here, So, although we've been sort of discussing and getting information from governments and lawyers, but we've been trying to solve their problems without really seeing how we can build up teams sort of maybe led by the IR community that really move the information retrieval problem forward. So in order to be able to do that, what other fields do we need to be working with? Information scientists, cryptography fields, politicians, so we've worked with governments, but politicians are actually the ones that will be coming up with the new policies and will be fighting for the new policies and will be arguing for them. So, they're the policies of the future. Maybe we need to get in now and sort of try and start planning ahead. So this general notion of, we're never going to solve this problem isolated by ourselves, but at some point it's probably going to come round to where we are in the position where we're saying, right, we need to solve it now, because there are legislations already that state how information systems have to act when they're available to the public and how they deal with information. And, that's just going to get more and more regulated as time goes on. So the pressures on the IR community to develop sensitivity aware systems is just going to increase as well as, the people who are in the jobs at the moment. So having said that, we've talked about a wide range of different problems and interesting parts of sensitive information retrieval at the moment. So what we have to identify what are the problems that the actual IR community is most interested in, and what you know, what would be most beneficial for individual groups to work on and stuff like that. And obviously the way to probably do that, which is certainly the approaches that we've maybe taken so far, is, you know, what's the next low-hanging fruit that we can actually address, so we can try and, you know, take an incremental and make inroads into all these different sort of areas that we've highlighted this afternoon. And with that, I think we come to the end of the slide. So as we sort of started saying at the start, we have a web page available. At the moment, there's the slides available on the web page, and there's also a bibliography reading list. So anything that you've been interested in today, you can go to that reading list and find inroads into how to you know, look into it further. Basically, we will keep updating this website. So we would have the intention, hopefully, that this is the start of a sort of maybe an interactive place where people can you know, add things or whatever. So we'd love to hear your feedback, your comments, you know, and what else we can make available through the website, and what other functionalities you might like to have there to you know, to help to develop the field a wee bit more and to have a broader IR community. I think that's it. Unless Doug's got anything to add.
So we've got, I've just put a note in the chat that says pick a breakout room. You should be able to zap yourself to a breakout room. And if you can't, you can put a note in the chat to everyone, please, not to me, because I'm going to be in a breakout room. The ECIR 2021 Vice will get you there if no one else can.
Excellent. Okay, thank you, Doug, and thank you everyone who's going to Doug's breakout room, and we'll see you all again soon.
And I'll stop the recording now, I assume.
Thank you.
Yeah.
Yes.